I'll switch us to science and tech for a moment. That Falcon Heavy mission was quite something. It's always cool seeing that thing go off, man. It's damn impressive. All right, let's roll, dudes. Get the tunage. That sounds right, Waymill. Yeah. I thought P63 was PDI, but yeah, now I have to go. I have to go look at the flight manual. But yeah, dude, even that, dude, like putting programs into a computer on a flight management system, like that's an important thing to understand, dude. What that Apollo capsule's doing, like the idea of having a flight management system and you program the FMS, right, to do what you need it to do. Every modern airliner has a system on board that looks exactly like that. Exactly like that. That's how modern planes work. You want to program the guidance system to get, to fly like an IFR flight plan on like a 737. Guess what? Start inputting numbers. For the FMS has all the routes, right? Because it has the waypoints for IFR, right? Start inputting that and make your own route, programming the computer with predetermined points. Oh yeah. Or just, well, the flight plan should have already been filed, so that you should just be able to plug it in and then go. But what time is it where I'm at, Kevin? 1:50 in the afternoon. Thank you. Makes it much easier to cut the VOD. Yeah, I got you. I'm trying to follow, but the button unclicks itself after a second or so. Does anyone know how common this problem is? Really, Huss? Hit Control F5 right now. It clears your cache. Hit Control F5 and then relog in if you have to, and then do it. Do you plan to make a large-scale prototype? Yep. Alright, let's get that to the right volume. And let's pick up where we left off. We were working on Project Hemi. Project Hemi is my vertical takeoff, vertical landing SSTO using thrust modulation for propulsive landings. If you can't follow, it may also be because you can only follow 2,000 people. Twitch has a hard limit. Didn't know that. Here we go. So, this is how far we've gotten with Project Hemi here. Now, this doesn't really look like much, but let me show you. Control F5 didn't work. I also only follow like 20 people. Yeah. Wait a minute. I'm a computer science engineer. I love the AGC. It's like learning the roots of your job and passion. Yeah, the hardware is really what blows my mind with that stuff, Waymill. Like, talk about, like, process-driven design, dude. Like, the hardware is, it's not like, what's the right way to say it? Like, so, like, I'm agreeing with you for what it's worth. Like, they had to make a computer for the software that they were going to write. But that wasn't even the right way to say it. That was just building something that can fly the spacecraft, dude. But can you imagine, like, who builds hardware to optimize around software? Like, how, I know it happens. I get it happens in aerospace all the time. But that's wild to me, dude. Like, we're talking about, like, the origins of, like, where that term software and hardware comes from in terms of, like, computers. They're doing that 50 years ago, man. Like, think about the state of technology in 1961. A transistor radio is high tech. A tube TV is, like, cutting edge. A tube TV. It's freaking wild, dude. Not 50 years, 62 years. Yeah, there you go. 50 years of gatekeeping. Can I share a link? Sure, Dayspawn. Yeah, a cathode ray tube. Alright, here. Check this out. Ready? So, I know this thing doesn't look like much, right? But watch this. So, with stock KSP, we were able to engineer a system. Now, I know what you're saying. Like, okay, it's hovering. So what? There's no thrust vector control here, guys. The gimbals are locked out on all the engines. Note that none of the engines are moving around. Also, this vehicle has a 750 kilogram weight on one side. And it's completely controllable. So, this vehicle has an offset center of mass and no thrust vector control, and it's just able to hover just fine. Oh, also, there's no SAS on this thing. There's just a probe for heading lock. No SAS, no gyroscopes, nothing. This was the first thing we designed because this thing is key. This thing is key to, well, basically landing the type of vehicle that we're going to make. So how this thing actually flies and how it's able to move around is I have RCS that can help me modulate thrust around the vehicle to balance for an offset center of mass. It's using modulating thrust vector controls to get the thing to fly perfectly level. If we turn the RCS off and we try to fly it, it's not going to get you very far. It'll just flip over and crash. Right? The idea that I got for this snow, yeah, exactly. Some new, it's from Stoke. Stoke is doing this. Yeah. Which, you know what I figured out, Snow, from doing this project? From even getting this far into this project? What Stoke is doing with that ring engine isn't just ridiculous, it's borderline insane. And the fact that it actually works is still kind of like, so you know how I basically I put RCS inside of my engines because what I tried to do was actually have a Cal controller modulate the thrust with the joystick to get the thing to fly straight. But the control systems for RCS basically with SAS lock is basically doing exactly what Stoke does. But here's the crazy part, dude. The only RCS on this thing is up there. Like a dedicated like off-axis thruster is right there. That's used for roll control. Just like mine has the RCS sitting up here. That's the only RCS on Stoke's demo, right? Which, the reason why that blows my mind is because not only are these things, the engines, when the rocket engine is on, throttleable, but if I'm understanding this correctly, right, that is also your RCS when you're going through terminal phases of like peak heating for reentry, or just it's your guidance system during reentry. Because there are phases, the thing's not going to fire its rocket engine all the way through reentry to keep the heat shield cool. No, it's not going to do that. But also, you don't want if you're firing the entire rocket engine, there's no way you have enough fuel. Because you need some fuel for landing. So how does it do it? Well, that expander bleed, the heat shield heats up. It heats up the cool propellants because the rocket engine actually has plumbing that flows the cold propellants through the heat shield. The heat shield's already going to get hot. But you don't want to turn on the turbine machinery either, like on the real thing when it's coming through reentry. You don't want to do that either. You'll run out of fuel. There's no way you could do an 8-minute duration burn with a stage like that. So that tells me that their expander bleed cycle is a system where they can shut off the turbine machinery and the rocket engines will pulse like RCS for stabilization during entry, descent, and landing. In the same way that we could fly this thing, if I flew this thing and shut off all the rocket engines and kept the RCS on, the thing would stay perfectly level. That's crazy, dude. What happens if you kill one of the motors in flight? Does it compensate? I don't think it would compensate by killing one of the engines, all systems. It'll gimbal lock. I don't think the RCS has enough oomph to be able to compensate. Like, if you think about how ridiculous that actually is, to have a toroidal aerospike engine that can also work as hot gas RCS using the same nozzles. That's really impressive. That's like you could change the industry impressive. I think there's a reason why Blue Origin was looking to try and do something similar. I thought this thing was planned to use the heat shield as a sort of aerospike as well. Well, yeah, for going up, Shimoda, not coming down. Yeah. Can't go back to the 1840s without a Lovelace, world's first programmer, and Charles Babbage's analytical engine, hardware and software developed lockstep almost 200 years ago. Yeah, Tessa, it's crazy. And even Turing, dude. Like, it's... I mean, I would argue that Turing was more of a software kind of guy, but also the fact that his brain was doing that in the 40s is just like... Single point of failure? On my vehicle, my vehicle can't compensate. To be clear what all systems and I were talking about, my vehicle does not compensate. I'm pretty sure Stokes probably could. Absolutely. They could modulate thrust on the rocket motors. Of course they could compensate. My guidance systems aren't as advanced as they are because it's Kerbal and not real life. So, like I said, I want to show you again just in case. Starborn to your brain as far as Stoke goes. It's really smart, man. This has the potential to be super useful. And in case you guys missed it for Space News the other day, Stoke announced that their Nova rocket second stage, that keg-looking thing, right, that I just showed you, that this vehicle is based off of, is also good for on-orbit refueling and lunar landings. That's within the company's scope of development to making the second stage into a landing vehicle for the moon. See, let's go up a little ways. So, shut the rocket engines off. See? RCS compensates perfectly. So, I think this system, how we ended up making this, is perfect. Once again, this thing has a 750 kilo weight sitting on one side. It's asymmetric, with symmetrical engines. Pretty damn impressive, right? So, have you tried actual re-entry with this thing? This thing's never going to see re-entry, dude. That's what the big vehicle is for. Or I could design this out to more of a subscale. We could go subscale with this thing if we want. If you scale it down, it might be better flying, but I know that's not the goal. Subscale could save time. I mean, I could do it, yeah. It would help me better design fuel, like fuel tank architecture and how that's all going to go together. How big is the final one going to be? Well, Pigzig, my stakeholder expectations for this project isn't just duplicating what Stoke is doing. Stoke is building this into a second stage on their Nova rocket. So the idea here is that first and second stage are reusable, and they have a reusable payload fairing that deploys off the top. I'm not building that exactly. I'm getting rid of the first stage and taking this thing up here and making it into an SSTO. Because I firmly believe that Stoke didn't come up with this by themselves. I think they looked at... I think the guy that's running Stoke... And don't get me wrong, I'm not trying to downplay what they're doing. What they're doing is insane, in a good way. That's really freaking cool. I refuse to believe that Stoke wasn't influenced in some way from, believe it or not, a Chrysler proposal for rockets in the 60s. Chrysler, the car company. Yes, the car company. Right there. Chrysler bid on the space shuttle program because Chrysler wasn't always just a car company. They were a defense contractor too, and they built rockets. They built the Saturn 1B's first stage. The first stage that the construction company dropped the other day, that's Chrysler. It's a Chrysler product. It's a Mopar for the car guys. Chrysler's SERV was their proposal to NASA for the space shuttle. Believe it or not, this is what Chrysler wanted to do. Their vehicle is fully reusable. But it's the same idea as Stoke. It's very similar. Oh, that's a really awesome picture of Falcon Heavy. That's DSN. It's the same idea as Stoke. You have a capsule-shaped stage, right? The capsule-shaped stage flies up, gets up into space, deploys the payload out of a payload bay, just like the space shuttle, and then comes back down and lands. But SCRV is a little bit different than Stoke. SCRV has these weird trapdoors on the bottom that cover up the engines during re-entry, which is a little bit complicated. And second of all, Chrysler, if you guys look at their proposal, there's JP4 tanks right there, because there's 26 turbofan engines, and it actually VTOLs with jets, which... That's probably the reason why NASA said, no, we're not doing that. Does the fairing pop off or clamshell open? Well, their idea is that it clamshell opens, John. My payload fairing is going to pop off in my design, because what I want to do is build this whole thing out. I think this has a better chance of being an operational vehicle than my Venture Star style SSTO, at least when it comes to the applications of KSP. So, the cool thing about it is that SERV could put a nose cone on the top, or they could put a payload adapter and have a crew vehicle. So SERV could launch crew and cargo, or just cargo, or if they're bringing something back down, just crew. So what I'm doing with this project here, and SERV was projected to have a 50-ton to low Earth orbit payload capacity, double the space shuttle. And then it could just come right back down and propulsively land. But once again, I firmly believe that the reason why NASA did not go with this design is because it has 26 jet engines in it. There's 26 jet engines straddling the wide diameter here, and during landing, the trap doors open and the jet engines start, and upward-facing jet engines flying backwards where the low pressure is probably not going to land very well. And that's also a lot of dead weight. And Pigzig, the crazy thing to me about this is that even with all those jet engines, the payload capacity was still set at about 50 tons. That means lugging all that extra garbage up there. JP4 fuel tanks, jet engine, 26 jet engines. Or it was either 26 or 28, I forget. They were clusters of jet engines at 12, 3, 6, and 9. So whatever 26 divisible by 4 is, which I don't think that works. So I think it's 28. Because there were clusters of 7, or 24 clusters of 6. But even hauling all that extra garbage and all this trapdoor stuff up there is still 50 tons. Which is still bananas to me. So we were talking about Stoke, and we were talking about SERV during Space News like a couple of weeks ago. Me and a viewer were talking about it, and You know, a viewer was like, hey, could you make this in Kerbal? It was actually Twisted in chat. Twisted Aviator. He's actually pretty cool dude. Pretty good buddy of mine, right? A viewer was telling me, like, could you make what Stoke does in Kerbal? And I'm like, yeah, I probably could. And then me being me was like, yeah, if I was going to make that, I would make it an SSTO in Kerbal because the Delta V requirements are not as bad as they are in real life. I would make it an SSTO and combine it with SCRV. And then my brain made the default text notification noise on an iPhone. It made that ding! And I'm like, I could make this. I could make this. Completely derailed the space news that I was doing. And we spent the rest of the night theorizing how you could get this done in Kerbal. And basically all I've been doing every time we played Kerbal is just proving it out and explaining what the heck this thing does. I do get a lot of questions about it because it is a little confusing. 24 engines total, clusters of 6. Hellfish. 24 comma clusters of 6. But, you know, subtleties in you don't really jive very well. It's okay. It's a shame they don't do a telethon for moronitis. It's a shame, Hellfish. You know, it'd be probably useful for you. I'm just kidding. You're a good sport, right? Come on, you're a good sport. Come on, come on, come on. Hey, how's the bed, though? The one you sleep in alone. I'm just kidding. You're a good sport. Come on, you're a good. Hey, look at this guy. You take a joke. You're good. Look at you. Anyway, what engines do you use on the big one? I haven't figured that one out, human person. This right here is more proving out that this can actually work, and I think there is premise here to be able to scale this thing up. No funny? No funny? No 9.5? Oh. Chrysler could have simplified some of it by having separate jet engines, using the turbopumps as the jets with an air intake bypass so it could be selectable LOX Atmo. So, Skylon engines. so Skylon engines. Alright, so, we're going to build a smaller version of this thing. Let's go new craft file. This is actually, you know what would be better? Oh, hold on. Hey Waz, 28-month resub. Thank you very much. Okay, so let's pop in here. But that would remove the need to carry them to separate jet engines. Turbopumps would do use. I mean, clearly NASA didn't go for it, dude. So yeah, I think if Chrysler had come up with Stokes' guidance system, but that would have been probably really difficult to do with the computers of the time. But if they had came up with something like that, I think NASA would have been like, Also, with a smaller one, you'll be able to dial in the proper ballast. Yeah, alright, so let's take this file, Project Hemi, let's go subscale, demo. VTOL thrust modulation demonstrator. This is the subscale, suborbital test vehicle. Modified 1013. Alright, let's roll. Pronounced fust. Alright, so let's go look at some scale designs here. So I need to look at some more blueprints of SCRV. I'm pretty sure I started making an SCRV research folder after one of the theory crafting streams. Yeah, SCRV research pictures. Yeah, see? Yeah, I saved that picture in here even though it's technically a diagram from Apollo, but it's applicable here. Here we go. Oh yeah, also SCRV was capable of carrying a second stage. Like the original, you should do shape offset rather than mass offset. Mass? Shape offset? What are you talking about? The vehicle was completely symmetrical all the way around. It's the architecture inside that made it asymmetric. Human. I've been reading a lot about SCRV lately. There's Aqualex's pictures. I've been reading a lot about SCRV lately, and I don't recall the shape being oblong. Like the original, you should shape offset rather than that. I mean, stoke. Oh. You're talking about how their heat shield is, kind of crooked? Yeah, you guys look, their heat shield is asymmetric. It's like kind of... So like if the stage is pointing straight up, the heat shield is actually like tilted down in one direction. If that's a heat shield, where's the flame coming from? Well, it's a heat shield. It's supposed to be hot. There should be flames coming off of it. Flykin, what are you, nuts? What's really the question you really should be asking is, why is there ice on your heat shield? Now, here, let me explain. So believe it or not, hey, Pythos, thanks for the raid. What you're looking at there is one rocket engine, despite having multiple nozzles. Rocket engines can have multiple nozzles in one power pack. The RD-170 has been doing it for almost 50 years. And the RD-180 has 2 nozzles, 1 power pack. This is one power pack, like 20 nozzles. Crazy, right? This is what I mean when I say Stoke. What Stoke is doing is like, you're doing what? Stoke has 1 power pack, and believe it or not, it's offset in the lower part of the heat shield. The reason why the power pack's actually below where the nozzles are. The engine fuel pumps are down here, and they pump up on a huge, like, Christmas tree looking manifold to the engines here. Why is the power pack so low? Well, lower center of mass gives you better ballistic stability, right? Center of mass always wants to fly first. Second of all, the pumps, the propellant lines come from the fuel tanks, and they go down to the heat shield and then go into the power pack. That's why the heat shield's icy. Stoke's stage here, the Nova second stage, uses the heat shield as a heat exchanger to heat up the propellants to drive the turbine on the motor. And the turbine dump for the 1 power pack, for the 1 engine power pack, is right in the center. Yeah. That's the exhaust from the fuel pumps, believe it or not. It's wild, dude. Yeah. So, the plumbing from this goes through the heat shield. Actually, it goes, if you really want to know, it goes from the propellant tanks to the pump part of the power pack, and the pump part pumps it through the heat shield, and it exchanges the heat, right? Most of that most of the exchange propellants gets mixed with oxidizer and finds its way to the rocket nozzles. But some of it taps off to the turbine, which spins the impellers, which turns the fuel pump, right? Like an RL-10. It's an RL-10 with the heat exchanger not just being the nozzle, because there's no nozzles. It's the heat exchanger is the heat shield. Yeah, weird, right? No one is making stuff like this. Nobody's ever made stuff like this. The closest thing that people have gotten to making something like this is SCRV, which was never made. It never got off the drawing board. Wait, so liquid rocket engine RCS, basically. You can... Flykin, my theory is that it could be used... You could just run the propellants. You could trickle the propellants through the heat shield and when you're going through re-entry, and it could heat the propellants up and spin the turbines just a little bit to get these motors to act like RCS for stability during re-entry. Or you could turn the whole damn thing on and start really spinning the impellers and switch these rockets. These rockets could basically switch between RCS and reaction control systems, or just like on rocket engines that are on. So, like, think about, like, each one of these things just being an extremely throttleable, responsive rocket engine. Now, I don't think I need to say, but I will just in case, how ridiculously complicated it can be It is to get a turbine fuel pump driven rocket engine to operate like RCS. But I think Stoke has done that. That's how ridiculous this thing is. In fact, they got Series B funding the other day to the tune of $100 million. Somebody's willing to throw $100 million at this idea because it's that freaking good. Yeah, so that should tell you everything you need to know. They're just building a Dalek. Yeah, right. Has NASA ever used an SSTO? They came close with DCX in the 90s bio, but no. So, with that being said, this thing is just designed to go up a couple hundred meters and come right back down. We did some high altitude testing with it to test its steerability with the offset counterweight. But what we should do is start coming up with a nice scale model here. So, this is going to hurt to do, but this is what we have to do because we're building a new version of this. Ow. Oh, okay. What was the reason SERV was never pushed further than the drawing board? Midget, it was the proposal for it was Chrysler's proposal for the space shuttle. That was their space shuttle design. Yeah. It lost to the space shuttle. Yeah. I think Chrysler's design was just a little too far out there for NASA at the time. It's just a little too far out of there. Wow, it looks so good. So, yeah. The reason why I needed to go back in here and start getting some... I need dimensions here. Here we go. Okay, this is all in imperial, so I need to take the imperial, convert it to metric, and then I need to scale it down. And NASA instead decided to stick a glider to the side of a giant external tank. Partially reusable upper stage. Hellfish, the crazy thing to me is that the space shuttle, out of all the ideas proposed, was actually the simplest. That was the simplest to do. But just because it was the simplest to do doesn't mean it's simple to engineer, right? In fact, the things that in engineering, I find that the things that are the most simple are in fact some of the most complicated things to design. That's just a kind of a principle of engineering. You know? Sometimes the simplest things are the hardest to make. Are the hardest things to design. Because anybody can make a design that does something complicated. Look at a Rube Goldberg machine. Engineering is about doing the least amount of work to solve your task. Which is an extraordinarily hard thing to do. Alright, anyway. So... cargo hold is 22.7 feet. Actually, we can use this time to get the full scale. To get the full scale prototype numbers here. I'm going to just write the numbers down because it's quicker. So, what's the diameter of the entire vehicle? So, I don't know why it says 1080 diameter. It's 90 feet. Wonder what that top number is. DIA? 1080 diameter? What system were they using? Inches? Alright, so Slow, you already did it, but I'll just put the calculations up. So we need to convert that to metrics. So it's 90 feet. So we need to divide that by 3.3. Because the conversion rate from feet to meters is 3.3. So that's 27.27. $9,000 centifeet. 1080 diameter, 90 radius. No, 90 feet across makes sense. That's 27 meters, so... I'm just going to write them down. I still write things down because I'm a dinosaur, I know. Okay, next thing. So, SERV from basically where the inner stage is. So that's the top of the vehicle right there. From basically the start of the inner stage to the bottom of the heat shield, we're looking at 66.5 feet. And 66.5 divided by 3.3. 20.15. I'm just writing out. Okay, cool. All right, so 27 meters wide, 20.15 meters tall, and it's cylindric, so yeah, our diameter gives us what we want. So the inner stage is 8.5. Let's get the payload bay, actually. Payload bay is 22.7 feet. Which, once again, if we put it in, I'm just converting everything over to metric because that's what Kerbal uses. So 22.7 divided by 3.3 gives us a 6.87 meter payload bay diameter. Okay, any other useful dimensions here? I just need to check something. Yeah. Yeah, that's what I thought. So, metric people, you're not going to like this. These numbers that aren't labeled in FT, those are inches. Yeah, because I just wanted to be sure. 1080 divided by 12, so 12 inches to a foot. 1 foot's about 30 centimeters. 1080 divided by 12 is 90. So, yeah, that's inches. Because frick you. Because frick you, alright? Because frick you. So, all these numbers up here with no measurement indicator, if it's not indicated feet, it's indicated in inches, which is just, alright. Because moon units. That's right. So, let's see if there's anything else that we can figure out here. Getting these dimensions would be super useful for our subscale demonstrator. So, like, even a dimension like this, 388.5 inches from the center line to where the shape goes from 45 to a 25 degree angle, super useful. Super useful. Let's just do that number out. So it's 388.5 from center line to there. I really wish we had a distance reference here from the distance of the interface from where the angle changes to the interface right there, the forward interface. If I had the distances between here and here, this would be really easy to make. What sort of scale are we going to go here? So 95, what I'm going to do, I need to convert all this imperial into metric, and then we need to scale it to Kerbal. And then what we're going to try to do is make a subscale version just to make sure that we can, just to make sure that I could do this right, that I could land one of these back from orbit. And then I'll make the big one. We can also use the subscale demo to figure out how we're going to do reintegration and stuff. So I was thinking the subscale would be about 50% Kerbal scale. Yeah. Because if I'm looking at these numbers, even a 50% subscale version is still going to be gigantic. It's still going to be pretty big. So anyway, let's go 388. 388.5 divided by 12 gives you 32.375 feet. Now divide that by 3.3. That gives you 9.81 meters. Let's see. What other dimensions could we use here? Anything else that's even remotely useful? We can get the interstage height. We know that the interstage is going to be at 45 degrees, right? And it's 8.5 tall. So we could, yeah, it's pretty much already solved for us. So the interstage is 8.5 divided by 3.3. That's easy. And that is 2.57 m. That shouldn't be too hard. Any other useful measurements here? Oh, we also, yeah, see, this is actually super good. We get the angle for the ohms, for the orbiter maneuvering, or the vehicle maneuvering systems here. We got RCS placement, engine placement. We don't need the lift engine fuel supply. We don't need the trap door. I'll just put a inset ring like Stoke, so that shouldn't be too bad. That's 25. That's a 25 degree angle. That's a 45 degree angle, and that's contiguous all the way up to the top, with the exception of the deorbit engine plates. Might have to do some fairing craft file editing for full scale. Well, if we take some of these numbers and we convert them, let's figure out some subscale numbers, or Kerbal scale numbers. So the thing is 27.27 meters wide in metric full scale. Kerbal scale is 62% for vehicle parts. It's give or take about 62%. So divide that by 0.62, and that gets you, or no, times it, excuse me, sorry. That's what I mean. Streaming gives you a math modifier to intelligence where you just really dumb at doing math sometimes. 16.9. $16.9 wide. I use 0.62, 95. It's give or take about 2/3, but I use 0.62 because the shuttle cockpit, I'm believe it or not, using the Mark III cockpit as my reference. The reason why I'm using that as reference is because that's exactly what the developers used, because the Mark III cockpit is just a shuttle cockpit, right? So that's contiguous between real life. We have the real life measurements of a shuttle cockpit, and then we have the Kerbal measurements of a shuttle cockpit. And that's one part that we can be absolutely sure is pretty much the same dang thing, right? It's not. One's in a video game, one exists in real life. Because, like, everything else is kind of like 2.5, 5 meter, blah, 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 right? The shuttle cockpit is absolutely what the relationship between real scale and Kerbal scale, because there's no other part that's so well documented and well known in Kerbal nor in real life, right? Everybody knows what a shuttle cockpit looks like. Everybody knows how big one is. So I use 0.62 because it's 0.62. I went and measured it a long time ago when I went and made a space shuttle. And, like, dude, you can change tank diameter, right? You can fake tank diameter with, like, a fairing to make a tank a little bit bigger or a little bit smaller than what it needs to be to line up. But since I can't scale a shuttle cockpit in Kerbal, I base everything around that. So my space shuttle, like, if I make a Saturn V in KSP, right, and I use 0.62 scale, it'll be the same scale as my shuttle. I use my shuttle as my rule of thumb because it's me, right? Because it's me. That's what I do. 20.15 times 0.62. This scaled to KSP, this thing is 12.49. 12.49 meters. And then the payload bay, 6.87 times 0.62 is, it has a 4.259. We'll just say 4.25 meter payload bay, which actually is pretty large. It's pretty large. And then the inner stage is 2.57 tall. 2.57 tall times 0.62 is 1.59 tall on the inner stage. And then, actually, we can figure out inner stage diameter right there, too. I should probably include that. So it's 142.5 inches divided by 12 is 11.875 feet. Divide that by 3.3, gives you 3.59. 3.59 meters is the diameter on the bottom of the inner stage there. And then get that into KSP times 0.62 is 2.23. Okay. Would be easier to just do a 5-meter cargo bay because KSC, but my realism. Scale is important in engineering, and understanding scale is super important if you're going to design. I learned that from CAD. I'm not budging on scaling like that. If I have to make a fairing that's just slightly smaller than a 5-meter diameter and it looks a little funky at the bottom, so be it. I'll cover it up with something. Giant dragon capsule with arrow spike. What's that, RJ? Oh, look at this thing. Ah, yeah, very nice, very clean. What's all the air brakes for? Those are your landing legs? So first stage, second stage forward skirt, capsule. So this is like 3-stage because you have the landing stage for your capsule, right? Is it, am I looking at that right? It's nice, dude. Looks good. It looks good, buddy. I like it. Very clean. Very clean. And you got some New Glenn action going down there. Nice. Looks good, dude. Okay. Now let's scale some of these numbers here that we see to KSP, or to KSP subscale. So we want subscale of what KSP master scale will be. It's 16.9, and then we need to times that by 0.5, and that gives us an 8.4 meter diameter. And then we have 12.49 times 0.5 is 6.2. 6.2 meter length. Hey! And our payload bay diameter, 4.25 times 0.5. We have a 2.12. Payload bay diameter. So our subscale vehicle is going to end up being a freaking small sat launcher. And then just some other units that I have. This is the interstage, 1.59 times 0.5. So 0.79 m. 0.79 interstage length, and then our interstage diameter, 2.23 times 0.5 is 1.115. 1.11. And then I need to do one more. .81. That's the master diameter. I'm trying to get, see that 388.5? I'm trying to get that one. So times 0.62, 6.08. Center to 45. Center line to 45 degrees is 6.08 meters, and then times that 0.5 gives you a 3.04. Okay, that's most of the measurements here. I think that's everything. You're literally almost on the limit of the fairing size with the Kerbal scale version. Okay. Merp. So you basically lucked out if you ended up doing a fairing design. Spoiler alert. I knew that already. When I was 95, the other day when I was talking with Twisted and we at the end of that Space News, when I was originally like conceiving the concept of this, I actually, if you go back in the VOD, I actually talked about it. I originally thought that we would not be able to build a fairing that diameter, right? And I was originally going to use tessellation to make a giant heat shield, and then, you know, actual reusable metallic heat shield, which would be cool. And Rocket Guy suggested a fairing. He suggested a fairing, and then I thought about, okay, what's the largest diameter for all the fairings? And yeah, I knew it would fit, dude. It just barely makes it. But yeah, now we proved it with numbers. I was doing that off the top of my head the other day. Like, once again, you can go back and look at the VOD if you want. All right, so we got our numbers. Let's get going on the subscale demonstrator here, dude. So let's plug these numbers into Kerbal. Dimensions, subscale, length is 6.2. Width well, actually, let's put that in as diameter. Diameter is 8.4 m. Payload bay. These are just the numbers that I just wrote down, dudes. So 2.12 meter. Did I ever do payload bay height? Did we ever? Is that something that we can check? Do I have another copy of this that shows this information? Nope, we're gonna have to go looking. This these dimensions are different. This picture has different dimensions than that other one that I have, than this. Like, this one is saying that we have a 272-inch diameter, which is 22.7 feet. That one says 15. So this, we might have different phases of the design here. Let's see if we can find more pictures to get more. That one says 15, and that's definitely Chrysler. They may have changed it. There goes the Pailista. 96. Maybe the rocketry form. I remember I went surfing around here and I found something that where I got that original picture from, but I didn't save all the other pictures because they had a bunch of. The only other picture that from that whatever that was is that one. Nope. I'll turn the music up. Do that tin eye search on that second picture. I think I'll be able to find it. Where are you, you punk? Maybe in here? See, yeah, with Wing Orbiter, that's definitely from the same presentation, right? Fonts match, everything. It says it's 23 feet wide. 23 by 70. That one says 23. That one says 23 by 60. That one doesn't even have a payload bay indicator. That one says 25 by 60. Do we have any images with a catalog number? You gave me an idea. You gave me an idea, dude. We gotta go digging for this one. We gotta go digging. Here we go. NASA technical report on static pressure distribution on SERV. Might be able to get something good from here. Let's look around. These numbers might be useful. I don't know exactly how you'd scale max Q into KSP. Here's the thing ripped apart. Oh, I see it. Yeah. Yeah, okay. So, yeah, that's cool, man. That looks good. That looks real good, RJ. That's actually kind of something similar to what I have planned here. Yeah, there's the arrow spike ramp. Frustrum. This is the fun part, dude. This is the kind of nerdy part where I need to know, I need to get a good grasp on what I'm building before I actually go to build it. This is the best way to do this. This is just technical reports on pressures. Nope. What's the next one? Yours can only fit 8 kerbals. Yep. Alright, let's try this one. There's no PDF, no preview. Finally, Space Shuttle Wind Tunnel basic data. Documentation and archiving of the Space Shuttle test data. Space Shuttle Phase B Wind Tunnel. Damn. The description did have dimensions, though. Oh! The baseline vehicle has a modified Apollo external configuration. "90 feet in diameter, 66 in height, 23 foot cargo hold, 60 long." Okay, so I'll go with this. 60 foot long cargo bay. So let's just get those numbers. 60 divided by 3.3 gives you an 18 meter length cargo bay. And then times 0.62, 1127. And then put that into Kerbal subscale, so times 0.5, 5.63. Okay. Alright, cool. I do love me some cursed fairings. What do you got? Tervas kansana tukas pala. Tukas pala. Another angle. That is a big fairing. That's a big fairing. Yeah. Alright. I got the dimensions that I need to keep going. So... where's my text? I hit undo. We mem-leaked the game. Undo in KSP really likes to break the game. And my measurements got deleted. KSP 50% subscale. Length is 6.2 meters. Diameter is 8.4 meters. Payload by diameter. Sorry guys, this is 2.12 meters. This takes a second. Payload bay length is 5.63. But we got the tunage. Interstage diameter is 1.11 meter. IS length is 0.79 meters, 790 centimeters. All right, that should be good enough to get started here. All right, it should be enough to get going. So first thing we got to do is got to map out these dimensions. I have the dimensions written out in Kerbal. Now we actually got to map them out. I got to basically make a workspace here for this type of vehicle. And I need to not hear finished poetry. Okay. Yeah, no, but if you love this morning's launch, it was good, man. Alright, I don't need that. I just did the conversion tables over there. I have them written down. Alright, so... so let's go with the length, 6.2 meters. So now we break out the rulers. There's a way to kind of more or less make rulers in KSP. Super useful here. Take 2 cubic octag struts, and then take a strut, an actual strut, and place them together like this. This is super cool for making straight edges, right? So now what you do is you take this thing and you go this way with it, right? And you can basically make an invisible line in 3D space, and you can use it as a ruler if you want to make fairings completely straight, for instance. Really easy way to do it. Now, we got to come up with the length of the vehicle. So I'll use a trick that I know about that you guys may have seen before. So basically take a mess of I-beams here and bring up your dimensions, and I just need to keep adding I-beams until our length is 6.2 meters for our subscale demo. That's all we got to do. Numbers right there. Length is 6.2. So right now, the total length of the vehicle is 6.4 meters, and I know that nothing else is sticking out here because I can move this back and forth, and that number doesn't change right there. So now, if I take this, we know that absolute snap is moving in 10 centimeter increments. There you go, 6.2 meters. That's the length of the vehicle. But now, if I go to build something here, I don't want the I-beams getting in the way of like when we're going to make fairings. So I'm going to take these rulers here. I'm going to take the rulers, and then we're going to move basically to the ends of these pieces here. And I'm going to move the very end of this and I'm going to, yeah, see, basically make it so the strut's just sticking out of the I-beams a little bit. And then move that over here like this. And do that. And then grab another ruler. Do the exact same thing. Oh, I think I set it to absolute snap by accident. The best is the best song ever made. Yep. See, right here is where it pays to be precise. I mean, we don't have any numbers indicating this thing's coordinate position in 3D space, but you know, get about as precise as you can get with KSP. The more precise you get these measurements, the easier the vehicle is going to be to put together. Like, dare I say, should do this with almost every vehicle. Alright, so there we go. We have the bottom and the top of the vehicle. Easy peasy. So, hit save. There's a mod called Precise Editor that gives you coordinates. Yeah. Cool. So, let's just take this here, and let's say that that I-beam is where the vehicle's going to end up. Right. We need to... Now what we need to do is come up with diameter. We need the diameter of the vehicle. So the outer diameter. What's our diameter here? 8.4 meter. I'm going to actually take these things and move them inwards a little bit for a second. Because we're going to have to do the same thing with the I-beams. Actually, it might pay to snap these things to the absolute instead of just eyeballing it on local, because it'll, yeah, it rounds it a little bit. So we know that's still right. Alright, so width. Right now it says my width is 1 meter because that's the length between there and there. So let's take an I-beam, right? Again. Take a beam. Put it in symmetry. What's our width? 7.1. We don't want that exactly. Make sure the beams are touching in the center right there. And then let's do that. So that's 9.6. That's not what we want. We're looking for 8.4. That's 9.4. Move that in a good ways. Right there. Discount Nirvana. Yep. Yep. Per the range, SpaceX is targeting 7:01 p.m. tonight for Starlink 622. Oh, damn. We started this stream with a rocket launch and we'll end with one. Now we're talking. Hell yeah. That's what I'm talking about. Cool. Hell yeah. Yeah, we got a... It's not a NASA launch, Nick, but we got a Starlink launch, which is pretty rad. So we're just getting our dimensions here. So we can, I'll get more connections here. It'll make more sense if you're looking at this and going, what the fuck is this guy doing? This will make more sense when we're done. So that's just an extra ruler that I have. We don't necessarily need that one. So now we got to start marking stuff, okay? We can get other diameters here, like payload bay diameter, right? But actually, payload bay diameter is what I probably should have done first, but that's okay. That's okay. There's other ways we can get that. So, what's our payload bay diameter supposed to be? Payload bay diameter is 2.12. Okay. So, let me take an I-beam here. Our length is set to 6.5 meters, so we could, you know, I can't use these things to indicate like width and height anymore because I already defined those, right? So we could use height if we really wanted. We could use the height axis for payload bay diameter, right? So we know that that thing right there is 1.6 because if I move it down just a little bit, it's still furthest. Our height measurement didn't change, right? So if I take one of these, right, I basically just got to use the height number and get that to 2.1. There we go, 2.12. And then center that right there. Bingo. Dunskies. So now, let's take that. That's our payload bay diameter right there. Right? So that's the diameter of the payload bay. Hey, American, what's going on, buddy? So the payload bay will be there. The whole vehicle will be like this. Now, the next thing we need to do is payload bay length. Payload bay length is 5.63. Now, what dimension could we use to get that? Well, we could use height again, I suppose, because the number's still lesser. So let's do that. Let's go here like this. Keep my original ruler piece right there. Just that's for copying, so I can easily build more of the rulers. Yellow EJ. What? Yellow? This is 3.2. And what number are we looking for here? 5.6. So add this and get our height indicator to read 5.6. So right there, height is 6.4. So we need to move this down here. 1, 2, 5.6. There it is. And if we line that up right there, that is your payload bay length. Copy 2 rulers. Okay. Actually, we only need one there because the upper terminus for the payload bay is the top of the vehicle. The inner stage takes up the extra space. So see, opening to payload bay, that kind of trapezoidal piece, payload bay terminates right at the top of that. And that, in the height measurement here, that wasn't included in the overall dimensions of the vehicle. Cool. All right, good progress here. I know it doesn't look much like a spacecraft right now, but... All right, save. And now, the I-beams that we used to measure, we can just get rid of them. We don't need those. And then the extra ruler we'll get rid of for now. All right, cool. Look, our spacecraft's making some really nice progress. So, now my question is where does that cargo hold terminate down here? I'm not 100% sure. Can you strap an engine on that right now and launch? I want to make sure it can fly. It doesn't even have a fuel tank. I know that's not an engine. Oh, I eyeballed that to symmetry. That's pretty cool. Okay. Let's start by building the payload bay. I'm thinking a 1.8 meter fairing here would be pretty good for what we want. Oh, well, actually, you know what? I have our where does the payload bay terminate length. We already have it. It's right there. And that payload bay is very much at the very bottom of the vehicle. So I got a little... we already ran into our first obstacle. Guys, if I want to do this down here, and we want to use this to make like a heat shield, right? Like that. You know, use the fairing to make a heat shield. Fairings make great heat shields, believe it or not. Right? I mean, the heat shield needs to be going out to this outer diameter. I need to make a downward-facing fairing plate, and the bottom of that heat shield needs to be right there. So we might, for our subscale demonstrator, we might have to compromise just a little bit on payload bay volume. It's the subscale demonstrator. I don't care. I think that's fine. What's VTVL? Vertical takeoff, vertical landing. All right, so next thing here. There's a bulkhead right here where the angle of the vehicle goes from 45 to 25 down to the bottom of the heat shield. Now, SERV has trap doors around the vehicle that actually open right there. We don't want that. I'm not doing that. We're designing it kind of like Stoke that has that recessed ring. So this is where we are going to have to start modifying the dimensions of this just a little bit to suit our needs. But doing it here on a smaller scale means that, you know, like when we go to build the big boy, it's not going to be too bad. But, you know, I'm sure longtime viewers have heard this story before, so, yeah. Okay. What's the max wide diameter on a 2.5 fairing? Like, how wide can it get? Can it suit our dimensions? Nope, we got to use a 375 plate down there. Yep, that's going to get us what we're looking for. Okay, so we're going to need those angular dimensions so I can figure out exactly where to start the heat shield for that recessed piece, because with looking at SERV, the trapdoor is covering up to basically where the landing legs are, and that's where the heat shield shape actually is. So that's where we can make this right here. We need to just, I'm trying to figure out with SERV how big is our recessed plate? What's the diameter there? And then from there we can kind of figure propulsion. So to do that, we're going to need a couple of more rulers here. We're going to need a couple more rulers, and then we need to set these rulers at the right dimensions. So we have payload bay diameter here. So I'm going to do a little bit of a trick here. Take this cubic octag right here. Go like that, and then put the ruler on that. And now, take that cubic octag piece, right? Put it right here. And then take that ruler and line it up with the one that I'm using to mark payload bay diameter, which is this one. The reason why I need that is because I need to figure out where that 45-degree angle starts. But in order to do that, we're going to need to get our payload bay diameter from an isometric view. So I need to figure out where this line is and where the angle starts for the outer shell of the fairing. Got to figure that out. Because if I don't define where this line is, I won't be able to figure out where that line is. If I can't figure out where that line is, we won't be able to figure out how big to make the heat shield. Where the engine mounts are going to go, where's the rings, where's the tank, where's the lower parts of the fairing, we're not going to be able to figure any of that out. Got to figure all that out. So, the reason why I did this is because I don't want to just eyeball moving it over here. So I put another ruler there, and now I'm going to rotate that 90 degrees. And that should jive perfectly with my rulers that are already on this two-dimensional piece right here. Perfect. That's our starting point. Done. Easy. Now this gets even easier because we got replay, another Zorg invention. It's even easier. So get another ruler, right? Is this the Atlas rocket? This is Chrysler SERV, which was Chrysler's proposal for the space shuttle, Jens. So now, move this thing up here like this, and we know that that leading edge up here is 45 degrees. Kerbal can rotate in 15-degree increments, so 15, 30, 45. Now what we need to do is find an absolute snap that gives us a little bit of a lip right there. I'll tell you why we need that little bit of space right there later. It'll make more sense. So there we go. Cool. So that gets us the 45-degree line. But how the heck do we know exactly where this will switch to 25 degrees? How do we know that? How are we going to figure that one out? Well, there's a measurement in one of these things right here, one of these drawings, and I made it pertinent to do this, 388.5, because I was thinking when we were taking measurements and we were converting all these numbers a little bit ago, that seems like kind of an arbitrary thing, but they wouldn't have that number indicated for no reason. So what this number is indicating, 388.5 inches, right, is indicating the center line of the vehicle to the angle right there. See that? That's where it angles from 45 down to 25 degrees out to the outer diameter, which is right here. That, we could use triangulation to find the exact length, but that's even that's overthinking it. We don't need to do that. All you got to do is take this line, right? All I got to do is take some I-beams, make them whatever that measurement is scaled in KSP, right? And just move it down the center line of the vehicle to where the end of the beam intersects the 45. Done. So that dimension I did take down. So scaled to KSP would be a 6.08 center to 45, and then in our 50% KSP subscale demonstrator, it's 3.04 meters. Easy. So once again, we can use our height here. 3.04. This thing is 3.2 meters, so I'm going to need one of those, which is 1.6, right? So we're looking for basically 3 meters on the dot. 3.2, 3.1, 3.0. There we go. That's a 3 meter I-beam. 3 meter long I-beam. So take this, put this on the center line, make sure the end of the I-beam is lined up with our center line indicator, which is basically our payload bay diameter indicator here. Move it down to where it intersects with our ruler planes here and put it right where the end is. There's the point. Done. So, copy another ruler. Move it out here like this. The line length doesn't really matter. So, Kerbal, on top of moving in 15-degree increments, right? If you toggle snap and hold left shift, it'll move in 5-degree increments. So, obviously that's 90. So, if we're moving in 5-degree increments and we need a 25-degree angle off of the center line, move it 5 times. 5, 10, 15, 20, 25. And now, just find a spot where these lines will intersect, basically right at the I-beam. Right there. There we go. Okay, you can get rid of the I-beam. And now, we have the exact lengths of the vehicle. It's just on a 2-dimensional plane right now. I'm basically making my own isometric image in KSP. I'm taking this image and putting it in KSP with scaled numbers. You want to build high fidelity replicas of vehicles, this is how you do it. Milo, it's your birthday today. Happy birthday, buddy. And that angle is directly over the landing strut. Yep, clues, Jens. The more lines you can define here, the more information I have to the dimensions of the vehicle, the more I can basically figure out how the thing was made. The landing leg lining up with this is not a coincidence. That's a structural bulkhead. There would probably be a big, gigantic aluminum cylinder in this thing. So, like if we were looking at a 3/4 view of this vehicle, right? So let's say this is SERV, right? It goes up like that, goes up like that, right? And then over this side it goes down, right? Like that. Straightforward, right? I'm going to go ahead and guess that there's probably... the structural designs probably would have called for something like this. A gigantic aluminum cylinder. And basically, that would have ended up being a common bulkhead. You know? Right? And then down here, that cylinder probably would have went down even more. right? If we just looked at this, right? And then the trapdoor mechanism would be right there. See what I'm talking about? That's what I could tell, like, and then the payload bay would have gone. Like that. The reason why I know that it probably would have adopted architecture similar to this, well, one, once again, it's from the lines. Two, here, take a look at this picture of Starliner. Take a look at this picture of Starliner under construction. See what I'm talking about? Oh, this is coming from US Launch Report. See what I mean? Cylinder with a cone on top of it. I think KSP missed an opportunity. They should allow us to import ISO drawings. I still think that would be a hell of a suggestion in Aviator, especially since KSP2 has isometric views. You know what? I'm suggesting that. Okay, cool. See what I mean? I'm gonna guess because SERV is capsule shaped that it's probably structurally made very similar to a capsule. Gee, weird concept, I know. You're telling me that the capsule shaped stage is staged and built like a capsule? What? Looking at SERV stuff, look at this, look at this. All right, what's up? What page am I going for? Starts at page 40. It has canard! You shut up. It's almost like taking this design and putting a delta wing on it would be the best way to do things. Like if you, instead of having the canards up there to get your center of lift to shift forward correctly, putting a strake right here, that's almost like that's the best design. Gee, I wonder why you would think that, because, you know, I'm telling you, man, there's a reason why the Soviets copied the space shuttle's aerodynamic design, because that shape right there is, I know it doesn't look like much, but that shape is perfect. It's perfect. Like, you will not get a better hypersonic reentry vehicle. The shape is, I cannot tell you how genius that shape actually is, and it came from all this testing. It came from doing all these tests, man. So much aerodynamic testing done by Dryden and actually Dryden and Ames. Like, that shape is brilliant. It's brilliant. Also, yeah, that's what happened when they went to deliver Columbia in 1979. It turns out that the adhesive that they were using for the tiles to glue the tiles on is water soluble. So when they flew the orbiter to When they flew the orbiter to Florida, where it's very humid, all the tiles fell off. Oops. Look at Columbia. What a beast. Glad they tested it. Yeah, right? Wait. Yeah, that actually... Dude, that delayed the shuttle program by a long time. Notice I said they moved Columbia... They moved Columbia to Kennedy in 1979. Kennedy. Kennedy doesn't build spacecraft, they launch them. So you know what NASA did? They didn't fly it back. They set up shop and basically built like in one of the OPFs and took every single freaking tile off of the vehicle and put them all back on with a different glue formula. It was called tile densification, and it delayed the program by 2 years. If you were here when I was doing that impromptu kind of space news explanation thing about budgeting programs and funding, do you remember when I said, like, the more stuff that you change later in the vehicle's development, the more costly and the more time it's going to eat up? Well, not testing the tiles, yeah, they paid for that. 2-year delay. Oops. No more oops. Yes. But yeah, anyway, Aglex, great picture. That's really cool. I mean, you could see that the space shuttle's design is in this somehow. It's there. It looks kind of like it, but not exactly like it. But it looks kind of like it. Speaking of said testing, page 40 again. All right, I should probably get back to building the vehicle. I made a bunch of rulers. Yep. Gee, funny how that works. Huh. Interesting. That really activates my almonds. Delta wings. Perfect for re-entry vehicles because of stable center lift. Center lift doesn't move depending on the angle of attack of the vehicle because it's a blended wing. It's a delta. It is a lifting body blended delta wing. That's what the space shuttle is. So basically, the more the bottom of the plane you expose, right, the more the fuselage of the plane ends up working like a wing, right? This makes it so, like, when the shuttle's nosing up, the center lift doesn't move around too much. So, believe it or not, the center lift is the same when it's doing this versus doing this. That's why that delta wing design is so ridiculous. Think about that for a second. So just consider this for a moment. Space shuttle could be flying at hypersonic, 45 degrees pitched up, going like Mach 25 into the atmosphere with flames all around it. And it basically handles exactly the same at like Mach 5, past re-entry heating. It basically flies more or less the exact same from Mach 25 down to subsonic. Subsonic is where it really starts to fly like trash. Yeah. That's ridiculous. That's nuts when you think about it. Not even a fighter jet can do something like that. An F-22 at 50,000... Well, actually, an F-22 at 50,000 feet is probably going to handle about the same that it does down here. F-22... Fighter jets can do that. But fighter jets can only do that up to like 50, 60, 70,000 feet. The shuttle can fly at 350,000 feet and fly the same at 50,000 feet. That's ridiculous. That's what I mean about that wing design. It's bananas how good it is. Like, the Soviets looked at it and went, oh, yeah, no, yeah, we'll just do that. Screw what we were doing is dumb. We're just gonna do that instead. Excited for Cities 2? Absolutely. Summer. It's just all those little things on that wing are designed to make it fly exactly the same, no matter how fast you're going, how much fire is consuming your freaking vehicle. Or angle of attack. It's bananas how crazy that actually is. There we go. Welcome to my life, American. Alright, anyway. Cool side note. Get rid of that, get rid of that. We are still teed up for a launch in about... what is it? About 3.5 hours. God. This will be 1067's 14th mission. Cool. Still can't believe a 747 can fly with a shuttle on top of it. It's pretty cool. Considering the Soviets had to build a custom airplane to move their shuttle around. And we just modified something that we already had. Seriously, NASA bought those 747s from American Airlines for nothing. Because American Airlines was switching to the 747-200. The NASA 905 and NASA 911 are 747-100s. They're like Mark I versions of the 747 from like the early 70s. Yeah, everybody was switching to the 747-200. And so yeah, NASA got the two shuttle carrier aircraft for like nothing. Yeah. That's why in the early pictures, like that picture of Columbia that I just showed you, right? If you look, 905 is still painted in American Airlines livery, just it doesn't have the American logo on it. You could see where it was, but NASA basically scraped the American logo off of it and said, it's good, whatever. By the way, what's up with the Falcon Heavy? Is it going to fly soon? Falcon Heavy flew this morning, Jens. Where were you? Psyche mission. Double booster landing. It was excellent. Yeah, see? You can still see where it says American on there. Fun fact. This American Airlines livery is actually like that's a government livery for vehicles. Yeah, it's government livery, and it uses the same font as the space shuttle. Believe it or not, it's all Helvetica, which is one of my all-time favorite fonts because it's Helvetica is the font that's everywhere and you don't know it. It's like the silent workhorse of fonts. It's very easy on the eyes to read, and it looks great. I wonder what they had inside that 747. Flask, they basically from here all the way back gutted it completely. Because if they'd kept all the seats in it, it wouldn't have been able to move this. True story. You're kind of getting close to max takeoff weight here. There's only seats right here, in the nose right here, for moving around personnel. There's like maybe 20 seats up there, and that's about it. Helvetica is a great font. It's my font of choice. And Futura. Futura too. Yeah, absolutely. That and TNR as well. Times New Roman. But yep. Yeah, see? Yeah. An easy way to spot a 747-100 is that it's only got 2 windows up there. You look at -200 and -400s, there's a row of windows. And the hump on a 400 is longer. Didn't the 747 also carry the shuttle in LDEF after STS-32 at the same time? Yes. 747 is one of the all-time best planes ever made, ever. And no one can change my mind. A380s are cool. They ain't the queen of the skies, okay? The fact that it took you guys another 50 years to make a plane that's comparable is hilarious to me. Nah, you're a good sport. Come on, come on. You know what I mean. It's a nice plane, but it ain't that. What do you consider the king of the skies? SR-71 or the space shuttle? King and queen. Right there. Would you keep it original and restore it and take the fire truckness away? No, just drive it or donate it to a fire department. Alright. Cool. So we got everything we need here. Now what I need to do is figure out... We need to figure out, because we're not going with a curved line that... Like, the curved line with the trapdoor. We're not doing that. So from here to here, that's basically where my heat shield is going to start. But, and that's the bottom of the payload bay right there. Oh, okay. Now what I'm doing is I got my measurements here. I'm just gonna sit back and kind of look at this. Now, I know what people are wondering. Why is everything on the same plane? Well, the vehicle is cylindric, so when you're dealing with a cylinder, you only need 2 dimensions. So profile and diameter, and that's it. Technically, you don't even need the second one. I could make it like this. You only need 1 for a cylinder. And say to yourself, what have I gotten into this time? No, the technical feasibility here is actually not too bad. Hellfish, this is... I mean, sometimes, like when we were doing Star Raker, it took me a week to get all this information kind of collected and stuff. And now, don't get me wrong, that's availability of source material has a lot to do with it. But where I'm kind of like, ooh, this should be pretty feasible is what I'm trying to tell you. Where I'm starting to get a little hung up here is that at subscale dimensions, getting all these fairing shapes put together to make the shape of the vehicle is going to be a little bit prohibitive. It's going to be prohibitively difficult. Especially with the shape. What kind of shape do we want here? So we gotta think about some things here. So this is the spot where the propulsion is going to go, right? Because there would be a trapdoor in the design right here in real life, like SERV wanted the trapdoor. We're not doing the trapdoor. We're doing a recessed toroidal spike like that. So instead of like curving all the way down, we need to do something exactly like this. So what does that shape look like? How big of a diameter of a motor are we going to use here? By the way, that PDF with the weird SERV, with that huge spike, has the correct outer shell. That diagram is the one-double article, and the spike is held. The bulb in the back is the correct shape for SERV starting at the front of the cargo bay with a hard point. Sorry. Oh. We also had to remember that the proposal was likely not going to be what it ended up looking like. Yeah, I understand that, Hellfish. So, when I originally conceived this idea, I anticipated that. Filling in the blanks with other designs is how I would overcome that problem. Trapdoors? Nah. We'll do this. Landing it, re-entry. That makes way more sense, and it's a similar idea. So I was like, oh, I'll use Stokes' ideas to fill in the spaces of SERV that weren't like completely fleshed out. That was the idea. They fit. You'd be surprised how good it fits together. But, like I said, I refuse to believe the guys the leaders of Stoke haven't looked at SERV and said we should do that. And come up with their own way of doing it, you know? Yeah, I did. Oh, excuse me. I did notice that, Aqualex. It's using a recessed aerospike ramp.
Discovery, go and throttle up.
It's using an aero. This is much more like a toroidal aerospike ramp than it is. Like there's no trapdoors in this wind tunnel test article, which is surprising. Hey, Battle, 14-month resub. Yeah, it is kind of looking more like Stokes. All right, so we don't need the exact scale numbers here for this particular shape. Oh. What's our 2.5% scale, like you said? So that's 27 inches. What unit are we working with here? That's inches, I think. SERV is an SSTO. Stokes Nova rocket is a second stage. Yeah, I noticed that. Though if Stoke scaled up to an SERV, I think they could do it. I think they should do it. I think Aqualex, this is one of EJ's tinfoil hat aerospace, where the aerospace industry is going ideas, like Starship out of the VAB crazy. I think that Stoke will eventually move to this. But what most likely happened is that they looked at SERV and said, this is too complicated to make for our first try. We need to make a subscale demonstrator. And then from there, they were like, oh, don't make a subscale demonstrator. Make it a second stage. That train of thought, I'm not saying that that's what they're doing, but I'm saying that that makes perfect sense to me. You know, you're going to make a toroidal aerospike VTOL capsule, right? So you can go two pathways with that. Go DCX, right? And just build DCX and try to SSTO that thing. Or you can make a first stage for it and basically make Nova a subscale test demonstrator for refueling, landing, yeah, and then scale up from there. Imagine how dangerous SERV would actually be in a launch environment like this. 50 tons to orbit. That's more than Falcon Heavy, and it's fully reusable. I think it's the investors. I think it's more the investors would be too scared to do SERV. Probably, yeah. I mean, a lot of the time, you know, investment limits design scope. That happens. But anyway, what unit of measurement are we working with here? Is this inches? If it's inches, I can. What they have here, if we're working with inches, we have a heat shield radius right there, 31.35 inch radius. So that's the distance from here to here. If I can scale this number back up to 100%, right, and then put it into Kerbal, I should be able to get our heat shield diameter, and then the ramp diameter should fall into place from there. Imagine they make a version that could go on super heavy. The rocket would look like a mushroom. I mean, we're seeing decimal points here to the third decimal, so tenths, hundredths, thousandths. So that's 6.8. That's 6.825 thousandths of an inch. It's got to be 4525, just like we already did. Oh, this tells scale. I don't know why I didn't see this before. Those are numbers that could be pertinent. It gave me the length of the 25 line, and it gives me the length of the widest diameter to the end point. So if I take these, if we take 5.016, and it's 2.5% scale. This is 2.5% of the actual thing. How would we get 100%? It's getting a little late in the day. I know this is simple math, but my brain's starting to go because I've been up for a long time. Divide by 0.2, Brahms? So what did that one do? That sounds right, but sorry, I'm starting to lose steam here, and it's only 4 o'clock. I don't like that. Oh, ratio calculator. Cool. Divide by sides by 0.2. Vertical takeoff, vertical landing, Inky. Inky, you know like how SpaceX's Dragon capsule has, the Dragon 2 has those thrusters on the side, and how SpaceX was like thinking about doing propulsive landing with the Dragon for a little while? Take that idea, make the Dragon capsule the size of like a Saturn V first stage, and just use those thrusters to go all the way up, heat shield, all the way down, propulsive landing. This is SERV, Inky. Yeah, Chrysler, not Boeing, but yeah. Starship, the second Starship flight hasn't launched yet, Jens. They're waiting on environmental assessments from the Fish and Wildlife Service because the fish are upset or something. So, Brahms, refresh me. So that's 5.06 inches. So that means if we times it by 0.2, that would be the length at 100% scale, if that's 2.5%. Am I thinking about that right? So that means that this length on the actual vehicle would be 250 inches. Here, let me see if that works. It's 2.5% scale. Hold on. It's 2.5% scale, so 5.016 times 0.025, right? Or no, divided, excuse me. 5.016 divided by 0.025. Yeah, okay. The calculator I linked gives you 200.64. So that means 1-to-1 scale. So if we divide that by 12, that get 12 inches to a foot, that's 16.72 feet. And then in metric, we divide that by 3.3, and that gives us 5.06. 5.06 scaled into 1-to-1 Kerbal scale is 0.62. So 3.14 pi. And then scale that to our subscale KSP demonstrator, we'd do times 0.5. 1.57 meters. 1.57 m. 1.57 meter outer diameter to bottom. Bingo. This is going to be super freaking helpful, actually. That's a really useful measurement because it's a measurement I don't have. .141333 is not pi, by the way. I know. Someone else mentioned it in chat. That wasn't aimed at you. I was gonna say Signer. I'm like, what? Dude, you, why? Why? Okay, so what we just figured out, which one was the measurement that we messed with? We have the length of the outer diameter to the bottom. So this we should pick up it pretty much exactly 1.57. Oh, that's super useful. I know that these I-beams are 1.6 meters, so 1.57, just round it up. Perfect. So now I know where the outer diameter of the vehicle is. That's the bottom of the vehicle. That's where the payload bay is supposed to start. And then that's where our outer diameter is. Ah, score. That was huge. Good find, dudes. Good find. Once again, I'm basically building a 2D image of this thing right now. That's the diameter right there. Oh, that's sick. Perfect. Now we can use more of that. We can use more of that. That isometric picture is so freaking useful, dude. We can move those there. Notice me, important. That's not the bottom of the forward arrow shell. That's this. That's to the center of the radius at the bottom. What? Yeah, Signer 3.141592638, I think. Begin again, it's not to the bottom of that forward arrow shell, that's to the center radius at its bottom. This? What are you talking about? Or are you talking about this? Plus mark is center of the circle. The radius is marked out at the bottom of the drawing. Is that not the radius of the heat shield? That should be what that's referencing, no? Or is this referencing... I'm confused. Are we sure? No, I'm not so sure. So what's deref then? Diameter reference, 27 inches? How does that... How can that be more than that? That doesn't make any sense. Now I'm really confused. Is there a key for this? We're talking about this. Okay. We didn't take this measurement here. Datum reference? Yeah. I didn't take this measurement. I took this measurement. I'm just looking for the widest point reference to the bottom of the heat shield. That was the thing I just took. What did you think we were doing? I'm confused. I understand there's a curve in there. I can incorporate that into the fairing shell, more or less. Okay. Okay, I mean, yeah, I get you. This would mess you up if not accounted for, because without the radius, the angle won't match up with the widest part. You're talking about that sucker right there, right? Yeah, okay, yeah, no, I got you. And how this doesn't line up with that. I get it. The widest diameter isn't necessarily where the outer shell of this vehicle ends. Cool. I mean, I got to re-engineer this part anyway, so... I mean, we could use that as reference. That's not a big deal. You know what? We should start marking these. There's a lot of these things. Flag pack with numbers and letters. Super useful, dudes. Just marking those should make the rest of these self-explanatory. Cool. Alright. No, I mean the widest part. I mean the widest part lands on the curve of that radius. So the bottom edge doesn't actually go out to meet the 25-degree edge, and that measure off a curve is something that regularly catches people off guard. That? It's fine. We can take that into account. That, I'm not... Dude, that's shape, and I understand, like, being exact, etc., etc. I'll make it look nice. As long as I have this length, I can visually make it look exactly like it. I'm not too incredibly worried. Can I have a link to this document? Sure. Alright, so I need to figure out the diameter of the heat shield. If you look carefully. Okay. I see it, man. I've been telling you. Brain's starting to sizzle like bacon. I understand. What does this have to do with finding the diameter of the heat shield? Because that's what I was trying to do before you brought this up. I don't... Is this just tangentially related to that, or like... I don't understand. Does this have anything to do with that, or is it just something that you noticed? Because now I'm just confused. Now I'm just confused, dude. It was carried forward from before. Sorry. No need to apologize. I'm not saying like, oh, shut up, I'm trying to figure this out. I was just wondering if this has anything to do with me trying to figure out the heat shield, because I still don't know how to do that. I'm still failing to figure it out. That's where I got hung up. You don't need to apologize, dude. You don't need to apologize for helping me, unless I say don't help me and you still do. Then in which case piss off. But no, that's not the case here. That's not what's going on here. I'm trying to figure out how we can do a stoke right here. In order to do that, I need heat shield reference. I need the if I could get the diameter of the heat shield, we'd be set. It would be really easy to get this right. But yeah, I do see the curves there and everything, and I can make that look right. I'm not too worried about it. The rest of these numbers we pretty much all have. But this is 3. You guys keep saying this is 3.0 R, and I'm not 100% sure what that means. Obviously, R you'd think would be radius, right? But why is that a 3? Why is that 3-inch radius, and why is this 31-35 radius? Or is that the length of that line? It might be. Two different circles. Okay. Thing looks like a bullseye. The closest we can do with this is to recreate it in CAD one moment. Yeah, there's a Schlieren mirror there. This is a mock-up of a wind tunnel test article. Or not, it's a blueprint for a wind tunnel test article. Let's see if there's anything else in here. Let's go to page 662. Man, that's going to take a second to load. Jeez, that's a lot of references. Yeah, source. Where I'm looking around for the table. That's why I kind of started scrolling back towards the top here. We have a definition for deref. I don't see any definitions here unless I'm just getting tired and glazed over it. Oh, bingo. Here we go. Nomenclature. So, just D is diameter. Model reference diameter is 27 inches. That's something we already knew. AB, area of throat, angle of attack, pressure coefficient, engine thrust. Tu caspala, Santa Kipine, 100 sparks. These are just pressure coefficient tables. The spaghetti coefficient of force, I swear, Vin, if you break the spaghetti, I'm gonna be pissed. Yeah, I was hoping for documentation. Yeah, well, Source Connect, that's the secret of this whole thing. You forget, like, from what I can tell, you forget most of the stuff you learn in aerospace engineering school, and you usually have to just go and reference it. You just go reference it. It's usually referenced in papers. You just got to understand what the frick it means, and that's what going to college for this stuff is. It's understanding what the hell all this stuff means. Or you could just be a stubborn prick like me and just try to teach it to yourself. That takes a lot longer, but it's free. You can even make money off of it if you want. Sounds we need destructive testing on spaghetti? No, we do not. We do not need to do any SFEA. Spaghetti. No. Yeah. Spaghetti finite element analysis. We do not need to do that. How many are there? 36 months. Counted them myself. 36 months. Counted it myself. I don't see anything about deref here. No Finnish poetry. Shut up. It won't let you share your anniversary. I was going to say, Lego, 36-month resub is, I think, is what you're getting at here. So that's got to be diameter reference here. So what is just R? Radius? It could be, but it could be radian too. Model radius in inches. Isn't smaller R radius? I'm not sure. Hey, RB. No. Well, this figures defines capital R as radius here. I have a thought, and you guys tell me if I'm just completely sniffing glue over here, okay? So, there's a way that road engineers calculate the radius of a curve. Because how the hell are you gonna know how to make the road turn, right? So there's a formula for it right there. You have to measure chord length. So, I'm actually interested here, because if you look at that PDF, right? It says this is 3135, and it specifically points to that curve, the curvature of the heat shield. And it would make sense that this would be wider than the actual radius of the vehicle because it's curved. It's a longer distance because the line, closest distance between 2 points is a straight line. So I'm wondering if we could use road engineering math here, which is basically calc. Well, it's not calc. It's not even calc. It's just math. Like, I wouldn't even call it a hardcore calculus or anything like that. I'm thinking that's the length of that line. That 3R is showing the radius for the outer body curve there. It's like this is like maybe algebra. I mean, I don't know what subset of math would this be. This is just chords because okay, so hear me out. If I can find out the distance on this curve, the length of the curve from T1 to T2 here, right? If we can figure that one out, you can get chord length. Chord length is the distance in a straight line between T1 and T2. If we can get our chord length in this particular, if that 3135 is what I think it is, chord length would be our diameter of the heat shield. We should be able to figure that out. Yeah, this is more, just straight freaking geometry, dude. And yeah, with a little bit of XS Mitch just got a little bit of 1.1 trigonometry on there. Is this 1.1 trig? Oh yeah. Oh yeah. So we got to find the chord here. Yeah, and how this pertains to road engineering, guys, is curves on a road. And this is one of the things that, like, you know, we're gonna play Cities 2 soon when that comes out. Radius of a curve has to be consistent. Varying radius around like a regular road, highway, back road, whatever, super dangerous. Because people will start driving around the corner and then the corner gets sharper all of a sudden and people go straight. That is especially applicable to highways. You have to have a consistent radius on every curve on every highway or else people are going to go around the corner at high speed and they're going to drive right off the track. Now, the flip side of that is that in racetrack design, variable radius corners, right, are actually a challenge to drive. And even race car drivers who know that the corner is coming still drive off the track. I'm thinking Parabolica at Monza. You know what I'm talking about, right? Have you seen Cletus's latest video? No, I haven't, RB. The 3R is the fillet between the straight part and the cone shape. Got it, Sparkier, yeah. I hate racetracks like that. Dude, reducing radius and varying radius corners piss me off, dude. They're so hard to get right. Guess you've never driven in the UK. Well, your roads are older than math. Old. I know that's not true. Shh. Quiet. Turn 1 in China is a good example. Yeah, that's uphill, decreasing radius right. And yeah, good example. Math is pretty freaking old. Math's a little older than roads in the United Kingdom, I think. Yeah. So, once again, let's see if we can use some of this to our advantage here. So, I think basically what we're doing is a simple curve here, right? Oop, no, not back into curvable. Not yet, at least. Where's that PDF? So, the length of that curve is 31.35 inches. And if we should be able to get this line from that length. I got a smart car. London roads are fine until potholes. Yeah, because your whole car is going to get stuck. It'll just drive into the pothole. Can't believe how fast Mo is going on just a 275 tire. Yep. So yeah, when people go to survey this stuff, that's how they figure out exactly how to make a curve or exactly how to build a road and get the curve to be perfect every time. Because math is dope. People who use math are dope and they like to do dope things. Okay? A simple curve has the same radius throughout and is a single arc of a circle with two tangents meeting at intersection B in this diagram. Compound curve is two more simple curves. Yeah, compound curves are what I'm talking about. Oof. go. A lot of math people do dope too. Yeah. Yeah, dude. Look at that. Look at that Fibonacci sequence of a freaking curve. Frick trying to drive that, man. Frick that. You'll notice that the simple curve looks like a compass. Because a compass in drafting is used to make curves. Weird, right? Where's the math? Actually, this is really good for explaining how roads are crowned. Oh, yeah. Yeah. See this? I love doing that in cities, man. That makes my day. Also using drafting for bending pipe sheet metal. Yep. See, I don't know the formula for this, dudes, to be honest. I don't even know if there is a formula. It's been so freaking long since I've done anything like this. I don't know if... I'm not sure how we'll be able to solve this with just the curve length. Maybe that's not... Maybe it won't work that way. Yeah, there might not be enough given information. We could just eyeball it, I suppose. Is the drawing to scale? I would say yes, this is a scale drawing, yeah. That looks about right. Talladega track curves are a nightmare. Put the center point of the circle 31-35 from the edge. Oh man, my bandwidth for doing engineering is running out for the day. The reason why it's so short today is because I spent the first 4 or 5 hours of the stream talking about Psyche and watching that whole thing. Which was fun. I enjoy that. What I'm saying is that when I'm running a normal schedule, when we start at noon, this usually doesn't happen until 7, 8 o'clock. Yeah, I think Aqualux said he could do it in CAD. In CAD, that would actually be super useful. Because CAD would just do the math for you. But I don't think I have CAD that's going to get the scale right here. I could just eyeball it. Actually, you know what, dudes? I still want people to do the math out. If you guys want to, because my brain's toast for it right now. It might be prudent to figure out propulsion for this at this point. Or just figure out kind of ballpark what we want to use. Personally, I think LVT-30s would probably be a really good idea. LVT-30s are not gimbalable, and they have a really small and compact design. I'm still good for just doing mapping out like this, Tessa, and starting to block out some components, dude. Not good for, like, doing super complicated stuff, to be honest. Let me just check something here. Oh, they have that weird, like, Thor nozzle thing. .265, 310. We're gonna need something where the sea level, specific impulse, and vacuum are kind of close to each other. FYI, the numbers here aren't quite adding up, so I'm going to get as close as I can. All right. Hey, Navy Vet. What's up, dude? Welcome back. Saw you were in here earlier. Yeah, that's not going to work. Single nozzle. No, that's not going to work because that's a poopy doopy engine for lower. 247, 260, 285 to 300. Just humor me for a second. All right, Antares, have a good night. What about the arrow spike? Actually, I mean... Was that 48 engines? No, it was 12. That motor, the Kodiak, has 4 nozzles, but it's 1 rocket engine, 1 power pack. I love the compactness of it, Tessa, where I'm kind of like, is that I'm going to have trouble making that look like this. That's my problem. I don't think we're going to need 24 of them in there, dude, to be honest. I mean, look at the size of the vehicle compared to the amount of engines. I don't think we're going to need that many. I'm actually pretty sure we're not. What's our payload capacity here? Hang on. Just, payload capacity doesn't necessarily scale, but I'll try to see if we can nail, you know, regular capacity. So 50 tons, 50 metric tons is what the actual one's going to do. So what it was going to do. Kerbal, that would be 31 tons, times 0.5, 15 tons. This thing should be able to move 15 tons into space in the subscale variant. Wow. That's impressive. Impressive numbers. So that's 9. Let me just see that one more time. 15.5. So I need something, need to see if we can find a fuel tank that's 6 tons to get the right combination. So that's 4.5, which means we're at 13.5. Now I need a 2-ton tank. Anything that's just straight 2 tons? That's 1.85, so that's good enough. I don't... If I had a need to, RB, yeah, maybe. Hey guys, who was here for my space news segment today after the Psyche mission? Do you see why that OIG report pissed me off? Just as per usual. See what I'm talking about? What am I supposed to do? What It's not his fault, Panta. Believe it or not, for a change, I'm actually not mad at Eric. The OIG, the Office of Investigator General, is basing their unsustainable pricing off of nothing. That's my problem. That's always been my problem. They say SLS is too expensive. Compared to what? Compared to what? Your imagination? The other moon rocket that we have lying around? What are you comparing it to? I hope you're not comparing it to the Saturn V, because there's not a chance in hell that SLS is more expensive. Maybe after it's all said and done at the end of the program, I talked about that earlier, but at this phase in the program, there's no way. There's no way that it's even close. It's not even close. So, once again, the last OIG report that came out, I invited chat to try and prove me wrong. What the heck are they referencing? Please, internet, try to be contrarian with me. I'm serious, because I still haven't figured this out. The OIG always says that SLS is unsustainable, spiraling costs, blah, 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 blah. Compared to what? You need to have a reference to say that SLS is too expensive. What is it? What are you comparing it to? I hope you're not comparing it to Falcon 9, because those are two different rockets. It's like comparing a semi-truck to a Volkswagen Beetle and saying that the semi-truck has spiraling costs. Well, yeah, that's because it's a semi-truck. A Volkswagen Beetle can't pull a 53-foot trailer. See what I'm saying? Compared to the captured UFOs that we have at Area 51. Yeah, rocket. See? This is ridiculous. And then, the reason why it pisses me off is because they go and say this stuff. They're basically pulling numbers out of thin air, saying that the program is not sustainable, and the press runs with it. That ain't the press's fault. It's not Eric's fault, to be honest with you. Like, don't get me wrong, I don't like that, but I'm not gonna... This isn't like a hot take. He's just saying what the inspector also said. The inspector, who was pulling numbers out of their tail. Compared to the amount of money they're willing to pay for it. So, what are our feelings? Just to note how much a moon rocket is going to cost, filler? Right? Like, even if what you're saying is joking, even if they were doing that, if you're not willing to pay to go to the moon, don't go to the freaking moon. Because guess what? All your hopes and dreams aren't going to change the price tag, dude. I hope that I hit the lottery tomorrow. I can hope as hard as I want. That's not going to improve my odds. It's just really frustrating, man. That's really annoying, actually. Duck Dodgers in the 23rd and a half century did it for way less. Tony Stark did this in a cave with spare parts. Yeah, Sparky, I got it. It's page 24 on this PDF. Be careful. It's a 795 page PDF. I think they compare it to the checks they get from the military-industrial complex that say if you cancel this and give us the money, we'll give you this much. I don't know, Tessa. Maybe. Somewhat related. It looks like the Ariane 6 rocket may not offer Europe any launch savings. You know what the interesting part about that is, Flask? I agree with Eric in that regard. The whole reason why I'm okay with SLS carrying the heavy price tag that it seemingly has is because there's nothing else like that. No one else has a super heavy lift rocket. No one else is getting to the moon anytime soon. Ariane 6, on the other hand, has a lot of competitors. I think it's kind of hilarious that a state is sponsoring a commercial launch vehicle. But yeah, I actually agree with Eric. Like, why is Ariane 6 getting made? Interesting, right? Because in that context, Ariane 6 has a bunch of contemporaries that are way better and way cheaper. Falcon 9. Falcon 9, for instance, when Vulcan starts flying, it'll probably end up being cheaper. Heck, even New Glenn supposedly should be comparable in price. But that's... asterisk that. Neutron. Yep. Ariane 6 offers nothing. Not reusable. Legacy components. Great. Not comparable in price. So why are we making this? Now, don't get me wrong. I kind of agree with Eric, right? But I also don't want to see less rockets being developed. Less rockets being developed is bad for the industry, even if it's redundant capability. More rockets that do the same thing means that the industry, the commercial industry, is very healthy, and there's the demand for it, which means more things are launching into space, which is good, because that can lower the price, because competition lowers the price. And also breeds innovation. But that's not what's going on here. Ariane 6 is being heavily subsidized. Basically, the taxpayer, in the EU taxpayer, is footing the bill for a rocket that's supposed to be launched for commercial profitability. And the fact that Europe wants to retain their own domestic launch capability, which that I can understand for national security payloads, that makes sense. That's probably the biggest reason. But if you're looking at Ariane 6 from a commercial standpoint, that's about as silly as looking at SLS for commercial applications. Just a thought. Look, we use metric and we paid the price. Leave us humble Europeans alone. I mean, and what I think what pisses me off the most about that, most about what's going on with Ariane 6 is that, and Ariane 5 for what it's worth, you guys footed the bill to make these rockets human rated, and you even footed the bill for development of a reusable spacecraft called Hermes. You guys paid for all this, they built all of it, and then Arianespace ended up using Ariane 5 to be one of the most commercially profitable rockets of all time. That's really annoying. What the frick, dude? That's always pissed me off. Like, if you're gonna sit there and you're gonna subsidize Ariane 6 development like that, guess what? Why don't you just go full 9 and subsidize your own human spaceflight program? You know, it's not gonna cost that much more money. No, they're going to use taxpayer monies to subsidize domestic launch capability and then launch it for profit. Which, are you guys gonna see any of that profit? Nope. Just saying, that's I have a real big problem with that. You know, you're cool to subsidize it when it makes you money, but if you want to actually go ask the hard-hitting questions, you get cold feet. That is bull crap, dude. I'd be pissed. Just saying. Atlas 5 sort of got the same treatment. Yeah, and it ended up becoming not economically viable anymore. God, funny how that works. I'm wondering if we could go with a smaller engine application here. Is there anything that's smaller that offers the performance and thrusts the weight of the aero spike? Not really. What's the Cubs? 280 to 310? And the aero spike is 290 to 340. Yeah, Flask, it's ridiculous. How can you screw up that hard that vehicle... I mean, don't get me wrong, Ariane 6's capability is fantastic. It's going to be a really capable launch vehicle in its own regard, but once again, they want to build it to retain domestic launch capability for the... How many satellite launches is that a year? 2? 3? The rest is going to be targeted for commercial endeavors like Project Kuiper, etc., which it already has a contract for. So that means right out of the gates, even before the rocket's even flying, more than 50% of its launches are going to be not used for its intended subsidized purpose, which is hilarious to me. Like, that's... What? Usually when I encounter something this ridiculous, I just chalk it up to me being a moron and not understanding the subtleties of what's going on over there, which I think at this point might be what's going on. Only the Rapier and SSME can compare with the Spike. Cone shapes are hard, Hillness? Yeah. That doesn't look too bad though, man. This line visually is screwing me up, so I'm going to put that temporarily just right there. So that's the wide point, right? See? I don't know, Aqualix, I don't know if he's still going in with the CAD stuff, but I see that space? I took into account the curve right there when I made that. Probably should have shown you that when I was trying to figure out what you were saying, but it's okay. I got you. You here? All right, cool. This really shows the delay in the landing of the boosters. There was a huge difference. Oh, headphone users. They're at the lighthouse. Headphone users also slightly unclassy language. Headphone users, you've been warned. This is gonna get loud. That's pretty cool. Thanks for showing me that, goalie. That's coming from Jay Concilis on Twitter. Did you throw this thing into CAD, Aqualux? What do we got here, buddy? Boop. That is a thing of the wind tunnel thingamajigger. Hey, Mikey! He's got a 5-month resub. Keep up the good work. I'm trying. Oh, he's trying! Oh, that that's what that radius is. I am really stupid. Look at you. Look at you. Well, looky here. Mr. Folges. What's up, sir? Smart. Yeah, okay. That makes that make a lot more sense. I couldn't figure that one out, but because brain is paste. Believe me, I see the links. You don't need to tag me. believe me, I see them. If you don't mind, I'm just gonna, you know, put these in my very happy place where I put very happy pictures. Yes. Oh, I saw it, Tara. Wait, no, I don't. Wait, no, I don't think so. Maybe if you, jackass. Maybe if you tag me again, I'll see it. You know what? You know what? You know where that picture's going? That picture's going into the shuttle research folder. Oh, yeah. It already exists. Nice. Thank you, past me. We'll just name it 2, just in case. Just in case. You know, just in case. Hey, funny you. What's going on, buddy? Yeah, I know, Tara. I know. It's what you do best. No, I need this. There we go. You learned from the master. Master ain't me. And there was also a sub from... Wait, what was that? What was that username? There was a sub 12 minutes ago from 394HEN35NU. 4-month resub. Thank you. What's the ISP of those engines? 280, 310. Not the most efficient, but good atmospheric, believe it or not. That's actually not the worst. The other thing I was thinking about is using the Bobcat engines. LeBron Crane. Those highlighted dimensions are the best you could do eyeballing it. No, you did, believe me, these are more than adequate for what we're trying to do here, dude. Yeah. I'm actually pretty sure I could figure this out with a fairing and stuff. Yeah, we could figure this. I could figure out that line with a fairing. I could do that. Yeah, I could use a fairing template to make that curve. Shouldn't be too hard. Our ramp, though, is going to be a little bit steeper than what the actual SERV has because we're limited by diameter of engines, which is what I'm exploring right now, why I'm looking at putting these Cub engines on there. Cub engines could do it, man. I'm just wondering if we're going to have the TWR. I mean, how much thrust do each one of these things produce? It's 28.9 to 32 at 280. 280 is not bad for atmospheric. That's okay. It's not the worst. So the 3135, the radius in inches of a circle, is the radius in inches of a circle of that arc. One of Aqualex's pictures is... Yeah, R3135. Yeah, it's got to be the radius of the heat shield. But what I'm wondering is that in the PDF, where's the point for that radius? It's not exactly shown, but the radius for that heat shield should be like over here somewhere. Should be a plus sign. It's out in front. Should be like over here somewhere. Well, that's still good to know. Actually, it's basically if you drew a line from here this way, we'd need to measure 3135. That's not the length there. So that chord using road chords is not applicable here. It's actually not that. That's overcomplicating the math. Oh, yeah, I see. I see you included it in your drawings. It's just up at the top. It's cut off. It's up there somewhere. That's fine. So you came up with a diameter of 22.5. 22.52. Let's do that. Let's figure out what that length is. So we need to scale it. So we're in 22.52 inches. At 2.5% scale, so times 0.025. No, it's got to be divided. No, it's got to be Eurobol. So that means in the 1-to-1 scale, the heat shield would be 900 inches. So divide that by 12. 75 feet. Whoa. A 75-foot heat shield? Are you kidding me? Here. You want to see what that is in meters? Here, let me write this down first. That in meters is 22 meter. Scale that into KSP times 0.62. 14.1 in KSP at 1-to-1 KSP scale, and then times that by 0.5 because we're doing a half scale demo. 7.05. Cool. You can see how much I had to wiggle the screenshot, so the area is super up to interpretation. This should be close enough for Kerbal. Remember, we're not... Kerbal is floating doubles, dude. The numbers don't have to be exact, and I'll be honest, a lot of these numbers I'm rounding to the 10th decimal place because Kerbal is not that precise, so don't worry about it, dude. We're well in the ballpark with 22. So, we're looking for a heat shield that's about 7 meters, right? So here's what we can do. If I take the Cub engines, right, flip them like that, take the first set and just move them in, right? Does that actually change the height of the vehicle? 0.5. Yeah, okay, so... There we go. That's good. Now take that piece and rotate it. And then get rid of those. And now, if I rotate these back 90 degrees, the height indicator should read 7, which means we have a 7-meter diameter here. And there you go. There's your heat shield radius. Did you see my post about Stormworks? No, but I'm scrolling up. Funny, you said you just went through a review for the latest rocket we're developing at the university and had one of those wow, it's beautiful moments. Hell yeah, man. That's awesome. Geek, where's your post? I don't see where this would be. You'll just repost. Anyway, funny you, that's awesome. What are you building the rocket for? Like, where's it going? This is coming from SpaceX. Just nice. Stormworks just put out 2 hot fixes today. Fixes the buoyancy and other gravity issues as well as jet engine altitudes. So all those people on their Discord made such a big deal and piss and moaned and went on entire tirades about how, you know, the developers don't care, blah, 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 and they patched it in 24 hours. Also, I really appreciate what's going on, like, right in this area here. Here is nice. That's cool, too. That's pretty neat. But right here, that's pretty... I like this. People are still freaking out and demanding apologies. Geek, you can hear what I'm thinking, can't you? Don't say it. We got a vibe. You can hear, you know exactly what I'm, you know exactly what I'm thinking. We don't need to say nothing. Not sometimes it's better to just say nothing. You can see the sound energy ripping through the exhaust coming out of the flame trench. Yeah. Can you? Let me see it one more time. Oh yeah, you can. Look at the ripples. Oh, that's so freaking cool, dude. I told you what was going on over there is cool. Now, you guys want to see something even cooler? All 3 center cores are throttled up to 100%. But, in order to make sure the center core has a longer burn time than the outer boosters, they throttle back the center core. Watch the center core's exhaust plume. Ready? Right there. It's small. It's small. Look at the center core. It's so small. It's so small. Look, it's tiny. It's so small. Think about this. We'll have 4 Falcon 9 cores fly today if Starlink goes. Yeah, look at this. It's small. This is a tiny exhaust plume. Also, that plume interaction is beautiful. Look at that. Nice. Slightly under expanded on the boosters. That's real nice. Didn't they initially for a first flight start with the center throttle down? Yeah, Blue, but starting rocket engines at 50% throttle is a real good way to break things. That puts, well, not break things, it puts a lot of strain on the turbine machinery, believe it or not. Yeah, you heard that right. Trying to start the turbine machinery at like half throttle could actually wear them out quicker. Because you're asking it to do something that it wasn't designed for. It's designed to start at 100. So, look, I guarantee you that despite the engine making more thrust and the impellers on the turbine machinery actually moving more fluid, that actually puts less strain on it. I guarantee you that that's what's going on there. That's so friggin' cool, dude. What a vehicle. What a freaking vehicle. You know, it's like almost a shame, dude. Falcon Heavy has so much to offer, and it's just gonna get eclipsed by Starship. It's gonna get eclipsed by it. I mean, we do have the bigger payload fairing in the pipe, and that's awesome. But dude, you know how like disgustingly good this vehicle would be if they gave it like Okay, let me put it to you like this. Falcon Heavy with an S4B and a J2 on the top would be disgusting. That would be a disgusting launch vehicle. Like you walked into the bathroom and there's poo like smeared on the walls. Disgusting. It's just that capability would be insane. Interesting, Oculus, yeah. Yeah, right, Jen? Mm-hmm. Why would we want that kind of disgusting? Because it would be a sight to see, just like a bathroom with poo smeared on the walls. You'd be like, what the hell? Seriously, though. Put a Saturn V third stage on top of this thing. I'm saying that like it's Kerbal and you can just click a couple buttons and do it. I fully understand the technical feasibility of that and how it really doesn't make sense to do. But man, this thing with a J2 on the back. J2 and an S4B with a 6-meter payload fairing. Oh my gosh. That's basically New Glenn capability. Yeah, you basically just made New Glenn. Hey man, I'm eating lunch. It's 5 in the afternoon. Oh wait, yeah, okay, you're over there. Didn't they once show an idea with an Orion on it? Daitor, the Falcon Heavy Orion idea was triple core, Falcon Heavy second stage, and then an adapter for an ICPS and Orion on top of that. Basically putting a Delta IV Heavy on top of Falcon Heavy second stage and making a 3-stage Falcon Heavy. That would be... I'd be a little bit worried about doing something like that. The reason why is because I don't think the second stage is designed to be able to take that kind of compression load. I don't think Falcon Heavy second stage was ever designed to have like 100 tons of something up in front of it. Maybe 20, maybe 25, 50, maybe you might be good there, but an entire Delta IV upper stage and an Orion on top of that, that's well over 100 tons of stage and payload. Yeah, there's no way. That's why I said just delete this part and put a Saturn 1B and a 6-meter fairing up there. In fact, screw it. Just put New Glenn's upper stage on top of Falcon Heavy. But yeah, it's still an awesome picture, dude. I love how the clouds eclipse the flames just enough to where it becomes crisp on the camera and you can see the under expansion from the cores. See how the plumes kind of go in and out? They have like an hourglass thing going on. That's because the ambient air pressure is actually pushing the flames back in on each other, and it creates this awesome, like, skipping stone effect. Serious question, why couldn't they just put two more Falcon engines on it? 2 more Falcon engines on what? What is a Falcon engine? Merlin engines? An Ares 1 upper stage would be... Actually got Ares 1 upper stage on top of this thing could probably do circumlunar navigation. Yeah. It'd be close. Give me a second, let me think. You'd have to use some of Orion's service propulsion system to finish the translunar injection burn. But yeah, it could do it. A little bit of perspective there. That's what Artemis 2 is doing with SLS. You want to know how much that ICPS sitting on top of an SLS booster is wasting a core stage's potential? If you put Ares 1's upper stage and an Orion on top of Falcon Heavy, it could do the same thing. Yeah, you're welcome. What's that? This mod allows you to do what Falcon Heavy did here. Oh, that's cool. Yeah, once again, Falcon Heavy. It's a shame this architecture won't ever be developed further out beyond like the gigantic fairing that they're putting on it, which is great. Falcon Heavy with a cryogenic second stage would be insane. It actually really doesn't matter which one it is. It could be a Saturn V, it could be New Glenns. Even a Centaur 5 on top of this thing would be... yeah, that'd be pretty good. So how much Starship could transfer fuel to orbit? How much fuel could Starship move to orbit as a Malak? A lot, dude. You know that stage that I'm talking... so the stage that I'm talking about going on top of Falcon Heavy is called an S4B. It's a Saturn V or Saturn V third stage or Saturn 1B second stage. That thing. Do you see that thing? That can fit inside of Starship's payload bay. Yeah. Easily. That whole thing, as you see it right there. And you want to hear the real kicker? You could fill that thing up with fuel and Starship would still be able to get it into space. Seriously. Look at the wet mass of this thing. Is it shown? Yeah. Prop mass. 109,000. So it's 109 tons. Gross mass 123. Starship could put that into space. Fully fueled. With payload on top. And have room for a 20-ton payload on top of that. Wow. That's awesome, actually. Yeah, Aqualex. We're not at that point yet, but it'd be nice to get to that point. No, gross mass animal. An S4B fully fueled, fully topped with hydrogen and oxygen is 123 tons. So that's minus the payload. Okay, let me put it to you like this. You'd have trouble fitting it. You'd have trouble fitting it in there. You could put an Orion capsule with its service module. It's 25-ton payload. Orion and the service module, 25 tons. You could put that on top of a fully fueled S4B and almost fit that in Starship's payload bay. Almost. It's close. I think it's just a smidge too short. And launch that into space. And you get the launch vehicle back. The only parts of the vehicle you wouldn't get back would be the service module and the S4B in this particular case. I didn't know what the words meant with the numbers. Yeah, the thing with the numbers. Can you believe that, dude? S4Bs are not small. That is not a small stage. Like, look at the dude. Like, you look at the railings next to it. That's a, what is that? What, like, 4-foot railing? Give or take, maybe a 3-4 foot railing. The stage is 6.6 meters in diameter, so that's 20 feet. give or take. It's like actually 21 or 22 feet across. It's gigantic. And it fits. That thing would fit, fully fueled, inside of Starship's payload bay. That's absurd. That's absurd. Starship is insane. It's insane. That's completely ridiculous. It's on another level of nuts. Alright, so we have our heat shield diameter here. Let me put a ruler down for that heat shield diameter. We can get rid of our payload mass for a second. Sorry about that, guys. See, fellas, this is the reason why I thought Cubs would be really cool. Because if we have the Cub engines in here, right, we can make the aerospike ramp. It almost, and this thing is curved in the front. It fits. And then you could still do an aerospike ramp and make this not look ridiculous. And if we centered it, we could even do a smaller aerospike ramp, you know? It's a giant pod. It's already ridiculous. Now the real question is, you know, how much thrust are we going to make from 12 of these things? We're probably going to end up needing more. Have we ever gotten a Falcon Heavy center core back? Yes and no. Some overclocking would probably do us right. RJ, yeah, that's not a bad idea, dude. Yeah, we could always overclock just a smidge. Yeah, I wouldn't be against doing something like that. Excuse me. So, Aqualex, the first Falcon Heavy center core splashed into the ocean. The second one from STP-2 landed on the barge. They couldn't secure it, and it tipped over and fell into the ocean. And then the third one also fell into the ocean. And then since then, they've pretty much been expended. So, a Falcon Heavy center core has done a propulsive landing on the drone ship, landed successfully on the booster, and then it was too windy and it blew it off the drone ship. Yep. And then every Falcon Heavy mission since then, I'm pretty sure has been an expendable core stage. I think. I'd have to look. So, yeah. That one crashed into the ocean. Something went wrong with engine ignition during landing because SpaceX was still trying to figure out the ballistic landing trajectory there. I mean, that and the center core's landing trajectory is absurd. If you look at it, it's nuts. Yeah, Arabsat was the one that landed, not STP-2. Center core fell over and was lost during transport due to heavy seas. 2 side boosters were used on STP-2. Yep. And then there's the space technology, the STP mission, space technology demonstrators for, yeah, NSSL. It reused the Falcon Heavy boosters. Center core did not land and was destroyed upon impact with the Atlantic Ocean. Yeah. And then there's SF-44. That was expendable, if I'm remembering right. There was an expendable Falcon Heavy. Yeah. So center scores seem to me like one of those things that would be really nice to get back. Interesting that they've done expendable since. Yeah. I think it's just the mission profile. And honestly, this is going to sound really strange. Especially considering how SpaceX really, really likes to get their boosters back. I honestly don't think there's enough drone ships. They only have 2. Well, they have 2 drone ships at the Cape, and they are never free. And in order to catch a center core, you're going 600 miles offshore. 1,000 kilometers downrange. All day. Probably even more than that. That was from the original missions. Literally the time it takes to get that drone ship all the way out there and all the way back, right? Just keep them for. It's better to just reuse the Starlink ones. The customer's paying for the rocket anyway, right? So just expend the stupid thing. Sending a drone ship all the way out there and all the way back, that's a long way for a boat, dude. Crazy, right? The fuel cost to get is probably crazy. I mean, amongst other things. Why then expending a brand new booster instead of a Starlink booster? It's because Falcon Heavy center core architecture failures is not Falcon 9 booster. A Falcon 9 booster has much more in common with the side boosters. Falcon Heavy center cores have much, believe it or not, have much more in common with Falcon 9 1.1. So, hear me out for a second.
Discovery, go at throttle up.
You're dealing, that interstage and the core, the booster core itself is dealing with 3 times the load of a Falcon 9 core. Why? Because you have 3 times the engines pushing up on it, especially on the top of the center core, interstage, and even up to the second stage. You're pushing with 3 times the force. So, because you're pushing, I mean, amongst other things, forget even the dynamic pressures that you're going to encounter there. But I mean, that shouldn't be too hard to extrapolate. Right? It's just 3 Falcon 9s strapped to each other. I know that's not how aerodynamics works. Aero does not work like that. Just because you put 3 of them together doesn't mean they're going to act the same as 3 of them separate. That's not how aerodynamic interaction works at all. I get that. But the aero simulation shouldn't be too bad. It's the forces involved. SpaceX has said multiple times that they had to build up and strengthen that center core and build it to a much stronger, stronger. I don't know if they meant with thickness or what, but consider this. The reason how I know it has much more in common with like Falcon 9 1.1 or 1.2 or something is because that is the point where SpaceX, right around that time when 1.2 and full thrust was flying, right? And then Block 3 and Block 4, right around that time is right around when SpaceX got heavy into the development. So this is Falcon Heavy. So this is like 2015, 2016, 2017, somewhere around there. So it makes sense that they would have started with what was like the norm for Falcon 9 at the time, which was like 1.2. That was like 1.2 full thrust in 2016, 2017. And then they started building off of that design, and a Falcon 9 design started converging away from a center core design. So the center core, like I said, has much more. It's much more in common with like Falcon 9 1.2 because that's the design it diverged from. Block 5 is diverged from Block 4, which is from Block 3, which is based off of 1.2. The design's separated. But SpaceX figured that out in development that, iterating on Falcon 9 as you built more and more of them meant that you could mess with the Falcon 9's design, right? But the center core doesn't have that because Falcon 9s were launching and Falcon Heavy wasn't, right? Because they were still developing it, right? The center core didn't have that maturity, right? So, because they had made modifications to make the center core stronger, right? Some of the modifications that they ended up introducing on Falcon 9 Block 4, Falcon 9 Block 5 never found their way into the center core's design. But I'm sure somebody at SpaceX was pushing for that, maybe Elon or something. I'm sure, I might be pulling this out of my tail, but I'm pretty sure that they probably pushed to make all 3 boosters uniform, but then, if you just look at Falcon Heavy, you don't really need the center core to be as powerful as a Block 5. It doesn't need to be. In fact, a center core favors Block 3 and Block 2 designs. So Falcon 9 1.2, Falcon 9 1.3. Anybody know why? This is a really difficult one. You'd have to go deep diving of Falcon 9 development. In fact, I don't think people even know this. The only reason we figured it out is because the only reason I figured it out was because of FlightClub.io showing simulation trajectories of Block 5 versus Block 4 versus Block 3. I'm pretty dang sure. Once again, could be pulling this out of my tail. Don't know. I'm pretty dang sure that Block 2, Falcon 9, and Block 3 actually have higher specific impulse than Block 5. Block 5 is actually less efficient. There. Yeah. You wouldn't think. Right? If you cast your mind back to 1.2, 1.3, they really couldn't come back down and land. Like doing RTLSs with those boosters, you were taking a huge payload hit, right? So, what do you mean they're more efficient? Well, think about it like this. What's the name of the game with a first stage? What is a first stage designed to do? A first stage is designed to get up out of the atmosphere as fast as possible. Efficiency isn't really the name of the game with a first stage, now is it? No. You generally want better TWR at the behest of efficiency. Look at a Saturn V, for instance. Saturn V's first stage, the F1 engines in atmosphere make 263 seconds specific impulse, which is atrocious. That's like a car equivalent of like 2 miles to the gallon. That is atrociously bad. You could fart and it would be more efficient. But you don't fart with 1.5 million pounds of force coming out of your tail end. If you did, I'd be really concerned. Right? An F1 engine is horribly inefficient, but it makes a lot of thrust. Where does Falcon 9's first stage spend most of its time? On the way up and on the way down. It spends more time down here than it does up there. Abso-freaking-lutely. Especially the parts where it's needed. Principal ascent. Doesn't need to be efficient. Block 5, Merlin engines that are on a Block 5 booster actually have lower specific impulse. They are less efficient. And now, I know what you're thinking. If you know a little bit about rockets, well, doesn't a lesser specific impulse mean you don't have as much delta V? So how are these boosters coming back down and landing, even though they're less efficient? Because you make up delta V if your TWR is high. Think about it. The faster that first stage gets out of the atmosphere and gets to a point where there's no air pushing it, the more efficient it is. TWR is the name of the game for efficiency, efficient flight trajectories with first stages. Right? So, where does the center core on a Falcon Heavy do most of its work? after the boosters have separated, because it's throttled down, like what we saw in that SpaceX footage, right? It's throttled down. They ramp it up after booster separation. Most of its job is up there, which favors specific impulse. Which makes sense because Falcon 9, Block 1, Block 2, so 1.1 and 1.2, and then 1.2 FT are more efficient. That configuration was more efficient. It has the Merlins make higher specific impulse, lower TWR. You ever notice that? Watch some of the old Falcon 9 launches. Look at how slow Falcon 9 goes off the pad. It's very slow. Because the engines don't make as much thrust, but they're more efficient. Weird, huh? So, there's a couple of reasons that I can point at Falcon Heavy and say, a Falcon Heavy center core is you can't just change the parts out and with a Falcon 9 regular rocket. They're two different rockets. Because, one, Falcon Heavy center core is way more efficient because it's based off of an older design, because when SpaceX did the development, it converged from Falcon 9's development, right? Or not converged, diverged, excuse me. I said converged before, didn't I? It diverged from Falcon 9's development. So it shares more in common with the older Falcon 9s from about 9 years ago, which are more efficient than Block 5s, which makes perfect sense. Cool, huh? Yeah, hopefully you learned something about Falcon 9s and Falcon Heavy architecture. This is not something that you'd go see on Wikipedia either, because, I mean, that's one of the benefits of me doing space news all the time. And you know, doing all these space news that we've been doing over this super long period of time and covering all these launches, etc., etc., you know, I see the development happen right before my eyes. The Falcon 9s from 10 years ago, guys, are pieces of junk compared to the Falcon 9s flying now. Like, the Falcon 9s from 10 years ago wishes. The Elon from 10 years ago wishes he had a rocket this good. You know? It really is crazy what that thing actually does. It still blows my mind. To this day, dude. Anyway. So we have our heat shield diameter right there. Okay, sound warning right off the start for everyone, not just headphone people. Alright, goalie. Do you wait until I open up Kerbal to post another link, or are you just the king of bad timing? Genuinely curious. You've done that 4 times now. I tried to get back into Kerbal, you're like, no, look at this. What are you building? I'm building a vertical takeoff, vertical landing SSTO Wartang. It's capsule shaped. I'm blocking out the dimensions for it now, so it'll be easier to make. But headphone users, another one. Nice. That's actually not loud at all.
That Sonic Boom is great for us. I'm sure Jim is excited over there. There's the second one. I'm sure the host.
Why is this in potato quality? This is just the cast, dude. Oh. I mean, Goal, you see, I mean, you know how humid it was today, right? Especially this morning. Look at this thing. There's so much water vapor in the atmosphere that Falcon 9 is instantly, it's compressing and then rapidly decompressing the air. And because there's so much water vapor, it just creates these crazy vapor cones right here. There's so much, basically what I'm trying to tell you is that so much water in the atmosphere that it looks like it's splashing through water right now. The humidity was super high this morning. Awesome. It never gets old, dude. It's so damn impressive what they do. I'm in awe by it, even after all this time. Anyway. So we could figure out the position of the heat shield, like where it is relative to the bottom, by picking up that radius there. So get rid of that for a moment, and then I need another ruler here. All right, all we need to do here is get... We need to get this thing to read... Oh, we need to do the scaling. Okay, so the radius there is 35.33 on that PDF, right? Like, radius 31.35. Okay, 31.35 divided by 0.025 means that the radius to get that curve right there is 1,254 inches. So divide that by 12. That's 100 104 feet. Yeah, that makes sense. Okay, so times that, put it into Kerbal scale. Now let's get meters. Let me put it into metric first. So divide that by 3.3. That's a 31.6 meter radius. Put that into Kerbal scale, times that by 0.62. 19.63. And now subscale Kerbal times 0.5 is 9.81. Okay. Okay, cool. Let's go back over here.
Discovery, go and throttle up.
So I'm going to put this down here. Hey, Hawk, 52-month resub. Thank you. And 9.81. So I'm going to keep closing this ruler up until that says 9.8. There we go. Got it. All right, so now we take that strut line, and that's the bottom of the vehicle, that piece right there. If I put that right there, give or take, wherever the end of this intersects with the heat shield is where... Oh, that actually was super close. Is where the bottom of the heat shield is. It's the bottom of the payload bay. It's the same. It's exactly the same mathematically. Word. So that means I can take my payload bay indicator and we can just move that right back out here. Because that marks the diameter of the payload bay, and that marks where the heat shield connects back into the shell. Damn, dude. This design's tight, man. That's what she said. These are my flag pack indicators that show where I use it to just mark what each ruler is so I don't get confused, so I'm not looking at a... So payload bay and heat shield. Cool. It's the same line. We can get rid of that. We have the diameter marking. That's heat shield diameter right there. That's heat shield length. All right, cool. Sweet. That's actually super useful. Most excellent. All right, dudes. Let's roll. And we don't want to listen to finished poetry either. Let's switch it up. I've been listening to Summer Car all day. Now we're talking. Okay. All right, so I think we got all the marking lines here. Yup. Yup, we do. Good. Perfect. So, yeah, overclocking, using 12 cubs and overclocking them is probably, I don't hate that idea. How many engines are on Stoat? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16? Because there's kind of one behind the... Oh, no, it wouldn't be behind the leg. Yeah, okay, so 15. Yeah. Huh. It's a very strange combination. I'm going to Costco. Want a hot dog? Yup! You were hoping for Goat Sim music? I'm not doing that. I was just wondering, guys. I'm not interested in putting 15 here. I'm interested in putting what we need. What we need to have here. The hot dog place closed at your Costco? Well, that sucks. All right, just out of curiosity here, let's mess with this. So, let's theorize. Let's say that this vehicle, let's overestimate actually. Say we have 30, it's a 36-ton vehicle, right? And we said that the payload would be 15, right? It'd be 15 tons. Well, first of all, how much Delta V does that get you? It's gonna be, yeah. I'm just doing some mass calculations out here. it's not 45. Oh, that sucks. We do have some room to play here. We could do that. And that basically aligns everything to the bottom of the payload bay. So that gives us 5,200 delta V, and we'll use sea level to calculate, because if it's enough delta V at sea level, it's definitely going to be enough in vacuum. We do not have enough thrust though. Fudge. There's a trick here. We can add more boosters. Hey Jasper, 44-month resub. Thank you, buddy. Yep. Dude, basically the top of the heat shield would be the bottom of the fuel tanks, which kind of is what's called for with the actual design. So, I mean... That's got 4,800... Here, put these down here. That's 4,800 delta V. That's atmospheric. What are we in vac? 5,400. And what's our TWR? 0.82. Crap. And we got to remember that this engine design is going to scale. We're going to have to scale it up later, which is why I wanted to really try and use Cubs, the Cub engines. That's 3385, but we have the TWR all day, but we do not have the delta V now. Six of them is 1.39 at 4,100 delta V at sea level. We get up into vacuum, it goes up to 48. Hey Jay, do you know how fast and what altitude the heavy boosters kick on for the landing burn? It's like 3,000 feet, Latte. So, actually, it's less than that. It's like 2,000 feet. So, like, no, that's not right. That's not right at all. 1 kilometer off the deck, so it's 1,000 meters. It's 33. Yeah, it is 3,000 feet. It's around 3,000 feet. That's a guess. That's a guess just based off of what I've seen. I'd have to go look at a SpaceX cast, and you could just see what the altitude is on the core stage, or on the boosters when they go to do their burns. It's not very high up off the ground. I think maximum maybe a mile. Yeah, maybe a mile off the deck, which is nothing. That's 5,280 feet, which is 1.6 kilometers. It's 1,600 meters. That's not a lot of time to slow something that big down. But it manages to do it, dude. How fast is it going when it starts the landing burn? I'd have to go look at the cast again, but if I had to just pull one out of my tail, I'd say like 400 or 500 miles an hour. It's a hell of a deceleration, dude. You wouldn't, I mean, like, say you were like riding the thing down, like if you were sitting inside of the interstage, you'd feel it. It would hurt. Yeah, you'd really feel that one the next day. Yeah, you might live, maybe, but yeah, you would really not be having a good time the next day. I think I would rather get hit by a bus. No. But seriously though, maybe. Thrust transform for those arrow spikes are in a very strange spot. So we have 3958 at 1.96 TWR. Yeah, that's with no payload. Not good. Not good. Not ideal. Yeah, that's not good. Night Sun Temple. If we put a little more pep in the toroidal aerospike's step here, we could probably get away with it. There is another option, though. People either love these things or hate these things. And I did make a rocket back in the day during mission mode 2 with these things, and it was actually quite good. I mean, these things are almost built for it. It almost fits it perfectly. That's 4600 Delta V, 0.75. Oh, come on, dude. You're killing me. Even 12 of them. 12 of them has 4,000. It's not bad. They're compact. What's the THUD's specs here? $275 305. Not the best atmospheric performance. The other problem is that the THUDs are they're heavy. They have a terrible thrust to weight ratio. They're 900 kilos for only 120 kilonewtons of thrust. Comparatively to like this, that's 1250 kilos and it's 200. But look at the vacuum thrust there. I mean, it's everything's a trade-off, dude. That would give us pretty decent payload capability. Let me see here. And once again, remember, this is a subscale demonstrator. This is more about vehicle handling characteristics, because this isn't the, believe it or not, this is not the finalized design. It's close, but it's not exact. 50 tons times 0.62 times 0.5. Yeah, we're moving 15. Ideally, if we actually did put this vehicle to work, we'd need it to move 15. So that would be, take this engine, shut out 2 of its fuel tanks. And then just because I like overestimating things, add another 5 tons of heat shield and whatnot. Actually add 10 tons of heat shields and anything else that you might need. That gives us 1.12 TWR at 3,800. 7 minutes for the launch? Huh? Whoa, wait, what? No. I thought... Oh, you scared me. Yeah. Daylight time for being across the pond. Yeah, I got you. You're on standard. We're still on daylight. No, I was like, no. Oh my gosh, is it time for it already? Yeah, we got another Falcon 9 launching today, dude. Out of the Cape. Falcon Heavy launched this morning. SpaceX just got another one teed up. Starlink 622. Whatever. Screw it. And then they got another one teed up for Tuesday. Because frick you. Because Starlink, baby. It's freaking absurd. It's absurd. Just how? Like, I ain't even mad. I ain't even mad. Did you see what the Phillies did to my Braves? I stayed up to watch that garbage. Yeah, you got dunked on, dude. Pretty hard. That kind of sucks. Alright, with these combinations, I want to try something. Let's try 8 arrow spikes. Let's see what the 8 arrow spikes gets us. 8 arrow spikes gives us 1.08 at 4,200. That's not bad. $4,200 Delta V. And that... Wait, did I shut the fuel tanks out? Oh. False positive. 10 tons of extra dry mass. 15 tons of payload. 1.08 at 3,400. Yeah, it's not good enough. Oh, man. We have a fuel density problem, dudes. I'm having trouble because the propellant mass of these propellants is not what this thing is originally intended to have. Both Stoke and SERV both have hydrolocks. And we have propellant mass ratios that are closer to methalox, excuse me. All right. Let's try a different configuration of fuel tank. That thing holds 720 and 880. What about some 1.8 meter tanks? We might be able to physically pack more 1.8 meter tanks in there. 810 and 990. Okay. You stayed up to watch that Super Bowl? You can't do it anymore? I'd be pissed too. That's all I'm saying. Won't you need verniers for control, though? Yeah, RJ, that's one of the things that I'm trying to balance out here. See, with the spikes, it's going to be really hard to get that exactly right. See, I can fit 8 of these tanks around, but I don't think... Hey, Kimbop. I missed the rest of the Star Raker build due to my appendix exploding. How'd it go? We got it to work, but... We got it to fly, Keen. I made it pretty much all the way into space with it, and then Starfield came out, so I stopped working on it, but I had to retool it a couple of times, and during one of the retools, I introduced a critical structural flaw, like the SSTO coming in and landing. That kind of flaw, which, yeah, there are scenarios where if you punch it with Star Raker, it just blows up. And my patience ran out with the slideshows. That and Starfield. Like I said, Starfield came out, so, oops. Okay. So what is going to get me into space? That'll give us the Delta V with those, but it will not give us the... Won't give us the TWR. I'm just going to place the engines here for now on the fairing, just so I don't have to go and sit there and place them every freaking time. We absolutely have the Delta V. We have no TWR in that regard. Clip tanks. We're going to have to, so I can make up for this extra area right there. Clipping tanks I don't have a problem with, once again, because mass fraction, etc., etc. Propellant density, differential propellant density, you know the drill. And same. We're going to have to do the same kind of thing that we did with Venture Star, where I had to clip tanks in to get them to work right. Thankfully, we don't need to waste time clipping tanks into fairings because the entire thing is a flying fairing, so it's fine. It's okay. It's okay. It's okay. .0, 153 to 180. 1.5, 167 to 215. So, I haven't really found anything that I like exactly. And these numbers are wrong anyway, because all of these tanks need to be locked out, because that's... So, the white tanks right there are taking into account payload capacity, and those two are taking into account just heat shields, fairings, any other systems that I'm probably not taking into account. So now we just got to find a combination of stuff that does work. So from there, I'll be able to see if we can clip stuff. What does this do? That's 2,400... We'd have to decrease the diameter on the heat shield. It definitely gives us the TWR, but it does not give us the Delta V, not even close. Nice, though. $22.69. Great. TWR is okay, but we don't have the Delta V. Nope. Those ain't gonna do it. Nope. We need a different fuel tank configuration. I think doing these in 8x symmetry is probably gonna get us what we're looking for. Does that fit? So once again, we got our payload bay dimensions here. Heat shield outer diameter. Regular diameter. So these things can basically fit right up until about there. Normally I'd be like, that's clipping a lot. I don't want to do this. But in this particular case, the design calls for the tanks to conform around the vehicle. Meaning that, you see the fuel tank is basically going right to the edge. Because I can only basically do cylindric tanks and I can't make this pill-shaped tank here with a kind of blunt, like, shape on the top. See that? That's the shape of the fuel tanks. It's like a pill with a piece cut off right there. And it has a different radius right there. Because I can't exactly mimic that. And that tank right there would have been shaped like a donut, believe it or not. That's what the design was calling for. Donut-shaped tanks. And the LOX tank is basically a ice cream cone shape, upside down and tilted. I can't fill that space. I don't mind doing clipped tanks because, believe it or not, we did the math out one time. The area that these two tanks are, the volume that these two tanks are clipped into each other is exactly the volume that would be taken up had I had a fuel tank that was the right shape. So clipping the tanks in 8x Sim is, I'd say it's perfectly applicable in this scenario. It'll work because there's going to be an outer fairing here, and I won't put, if I don't put anything where the outer fairing should be, or I don't put anything where the outer fairing is, should be fine. Where are those? That's not. No, I need one with a sharper angle than that. Okay, let's see where this gets us with, I don't know. Let's try 8 arrow spikes. 0.94 at 3,000. $31.68 at 0.88. Not enough delta V, not enough motors. Crap. This is getting to be difficult, huh? Freaking hydrogen, man. It's so cheating. Nice, Hillness. That's cool. None of these combinations are doing what I want. herder. One of those is almost enough. That's kind of funny. Nope. $1.14, huh? How much more fuel is this thing gonna need? To do that. Really? Nah, good idea, but not gonna work. It'll look awesome at takeoff, though, chillin'. Yeah, right? That's kind of why I'm like, dude, we should do that. But, I mean, what's the mass of the Cub? It's 180 kilos. Alright, let's start to get a little weird here. .63, huh? Oh, that was... Dude, no. No. That's just silly. That thing, I was thinking, like, clustering it, it's so freaking light, efficiency be damned, because that motor has insane TWR for what it is. $2,600, 1.41 TWR. That's great, but we're just not. It's not stirring the Kool-Aid, man. Dang, I didn't think this would be this much of a problem. This is something that I did not anticipate. I didn't think this would be this hard. What the hell? I don't get it. What about that? 1.11 at 34. Still not enough. Damn. RS-25 time? Well, the shuttle engines don't even have the Delta V. Alright, I'm making an executive decision and cutting the subscale mass down to 10 tons. Well, there's a heat shield there in the actual design, and the payload bay is there too, John. So, yeah. So I changed our mass down to 10 tons of payload and 10 tons of, like, these two tanks are payload and those two are extra mass. That's just RCS, deorbiting systems, anything that I'm not taking into account, you know? Losing that extra 5 tons of dry mass really makes a difference with an SSTO. So, like, for instance, if I put these things back on here, right? Where does 16 of these get us? Look, 16 of those gets us 3,900 Delta V, but it doesn't get us the TWR. What about if we had 40 of them? 68. Nope. Nope. Nope, 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 nope. Alright, that's not going to do what we want. Aerospikes. 8x aerospike with refined requirements. 3795 at 0.72. 4400. That'll probably do it. If we overclock the aerospikes, it would do it. I know it would. Well, it really depends on how much drag the fairings that we make end up having. So, what about 12 aerospikes? 1.06 at 3600, 4200 vac. Because you got to remember, I really want this number to be way higher. It's got to come back down and land, dudes. We got to propulsively land. So, we're really going to be at a premium here. Would this work better in KSP2 with different fuels and tweak scale? KSP2 doesn't have tweak scale, and it doesn't have different fuels. Except nuclear, which we have here. In theory, could you not shoot land? I mean, I could. Damn, I didn't think we'd run into this problem, to be honest with you. I was like, oh, there's got to be an engine that we can use. Just overclock some nukes. The problem is that the overclock would be insane because they make 13 kilonewtons of thrust down here. I thought too had a bunch of new fuel options. You have hydrogen, but hydrogen is only there for the nuclear engines. The majority of the rocket, well, actually all the rocket motors, save for the nuclear engines, either use monopropellant or liquid fuel. It's the same thing, just with a different name. But they did make nuclear engines have their own propellant, which I still do like. I always thought Kerbal should have different fuels. Hydrolox, Methalox, Carolox at the very Hydrolox, Methalox, Carolox monopropellant at the like very least. But the devs didn't seem to want to have that. They didn't seem to have that in scope for KSP2, which... Oh well. They didn't want to do it that way. They wrote a bunch of dev notes as to why. Like, I get it, but... NSF is online for the Starlink launch. Cool. Wolfhound nozzles are just too big. 700 Delta V. How much are we making vacuum though? 4,000. Yeah. This is a problem. We got a problem here. This is not good. It's Hydrolocks hired. So is Stoke. They're both Hydrolocks. Yeah, I'm really suffering from some efficiency problems here. Predominant redeemed add time. Morning. $3635.51. 4,000. I'm guessing you'll have to rely on overclocking. Yeah, pretty much hired. So we're gonna need to, what I'm kind of looking for. Yeah, we don't really have a choice. I need a motor that's, because we can overclock thrust, but we can't overclock specific impulse. So we need a motor. So we need a motor with with high delta V, a lot of delta V, but low TWR, and then we'll overclock from there. Which is why, once again, that's why I was revisiting. I thought doing this would be cool. Because if you look at sea level options here, 3,800 is close. In vacuum, this thing makes it to 4249. Not bad. You know, and I'll space them out. That's 24 of those engines, right? We could space them out to make it look all nice and even. And it's not the worst, but we're at 0.6, which 0.46 TWR, which means we'd need a 220% overclock on these motors. And then we'd have to incorporate the vernier and the RCS into this as well. And that would sap a little bit more delta V. But it's not bad. It's not bad. If this number was sea level 4,000, I'd be completely sold on this idea. Can you combo engine types? Yeah, of course, but I'm not going to, because that's not really in spirit with what Stoke is trying to accomplish and what I'm trying to accomplish with this kicks. But yeah, you know, in regular Kerbal play, sure. Now, my real question here is that where do the 8 arrow spikes get us? Do they get us the delta V? That's 4,500 delta V, 3795 in Atmo, but that goes up to, yeah. You got to remember, a lot of that is for landing. A lot of that is for propulsive landing. And I kind of have to take into account that this thing is going to have the aerodynamic properties of a brick because it's capsule shaped. So pretty much going to have the properties of a freaking brick. TWR with the spikes. 0.85. It's close. The atmospheric delta V is low, but honestly, all systems, we'd be hard pressed to find. You'd be hard pressed to find better atmospheric specific impulse. Test flight soon? No. Nah. 415, I'd say give me at least one more good hardcore stream of figuring out numbers and stuff and building the vehicle, and then we can do some hops with this thing. Oh yeah, no, Aqualix, Stoke's on another plane of existence, man. They're freaking genius, what they're doing. No worries, looks great already. Yep. So 415, what I'm doing right now, and this is the reason why I go slow with this design. You've got to think about what this vehicle is designed to do. I'm not just making a vehicle that I can just put on the pad, hit enter, and up into space. I mean, we are, but what I'm trying to tell you is that that's not everything this thing does. It comes back down. We have to figure out how to fly a capsule through space, through re-entry, to get a precise landing. We have to figure out a way to do that. I've never done anything like that before. I can precisely land my shuttle and we can precisely land first stages that come back down. But I've never tried to VTOL something coming back down from space, a VTOL landing coming back down from space. Believe it or not, in all my Kerbal career, never done anything like that. All of my stuff that comes back from space usually is landing on a runway, believe it or not. So that's kind of the other reason why I want to do this challenge, because it's something I haven't tried before. So, and second part of that is it's an SSTO. Like we have to budget the fuel. But also, what I want to do is I need landing legs for this thing. I want it to land, and I want to be able to build a truck like that thing that can drive underneath this thing, pick it up, and pull it back over to the pad. I want to reuse it. I want to see if we can do it. I'm building out all the infrastructure for this, and I think that's a really fun challenge. I love the idea. I love doing this. It's like one of my favorite things to do. Not just building out the vehicle, but building out the entire architecture. Right down to the truck that'll tow this thing around. That's my favorite thing to do in this game. First time I've ever seen someone attempt to recapture their orbital energy for reuse, with the heat shield being part of the expander cycle. Yeah, Aquilix, I think it's really smart. And I think the crazy part about that, dude, is I think that even when the motor is off, even when Stoke's motor is off, when it's, in the off state, right? The heat shield's still heating up during entry. So even with no turbine machinery moving, right, the heat shield's still heating up the propellants. And I think when you're going through re-entry, if the engine isn't on, your impellers aren't moving, propellants will still circulate in the system, i.e. hot gas will build up in the lines going to the rocket engines. And I think that those rocket engines will double as RCS for stability during re-entry. Yeah. It makes sense, right? Because you're not going to have the engine firing all the way down to landing. I hadn't considered it was landing like that. I always assumed SSTO meant landing on a runway. No, Reindeer. This thing... Check this out. This is a Haze Gray art video, and I won't show the entire thing, but this thing is doing this. This is what we're getting done here. I have to find a way to precisely land it. I have to be able to get it back to the runway, even if it's just a VTOL on. So that means this thing has to have the re-entry maneuverability of a shuttle. That is one of the hardest problems to solve. How? Look at Stoke Aerospace. They're doing something like this. Stoke's doing something like that with that thing. You want to see some black magic, dude? Watch this. This was actually like a couple weeks ago. Yeah, watch. You want to see how? This is how. Watch. Oh, headphone users. Headphone users. Headphone users. That's a rocket engine. That's a rocket engine. Does that look like a rocket? Does that look like Grasshopper going up and hovering? Where's the rocket exhaust? There's no, it's hydrolock, so there's not much, but you could still see the turbine dump getting heated, and that's what that orange cloud is right there. But what's really going to cook your noodle? How the hell did that thing translate? Do you see any gimbal? There's no gimbal on this thing. No thrust vector control. Modulating differential thrust to create translational movement. See any gimbal? See any thrust vector control? See any RCS? There's no I mean, it does have RCS, but crazy, right? That is one of the nuttiest things I've ever seen in aerospace engineering. That's right up there with Starship doing its belly flop. That's ridiculous. Actually, okay, maybe Starship belly flop is higher than this, but not by much.
Discovery, go at throttle.
Without the spike, there is no spike, dude. Yeah, it's just a heat shield down there. The gases interacting with each other will create the spike. Yeah. Just because, you know, looks a bit ugly. Ew, just got here. Mach 25 reusable. Acorn time. It's a hell of a typo, Zay. Something you're not telling us? I am too sleepy. Have mercy. I'm right there with you. I'm right there with you. We're going to the Starlink launch, and then I think your boy is going to be like, no. So, yeah, no, I'm right there with you. Oh, great, great. Now predominance here. It's like, wait, what did you say? What's that? Hey, you want to tell me what that? He's lived in Japan for too long, so you know what that does to someone's brain. You know, he hears words like that and goes, huh? Ah, leave me alone. Oh God. Have they discussed planned applications for this vehicle? Yeah, Reindeer. Actually, yes, they have. It's called Stoke Nova. Nova. Yeah. Dude, that I'm telling you, that engine is black magic. That's so ridiculously well thought out, it's kind of like sickening. Like, Reindeer, you remember back in the day when we made Enterprise and we got it working the first try and it just went up into space and was basically better than any other launch vehicle that I ever made, and I did it in a day? And how I was pissed off, like, because it was so freaking good? That's that in real life. I'm like, it's so good, like, I don't know emotionally how to react to this. Like, I get upset because I can't convey how freaking cool that actually is. I'm like, damn, it's pissing me off. Why? Because it works. It's so freaking cool. I'm like upset. I'm upset. Why does it work so well? Look at that thing. That's so ridiculous, dude. So yeah, it's reusable second stage tech. Basically, you know, the thing that usually gets put on top of a second stage is pod-shaped, and that comes back down just fine. So why not just make your second stage and fairing pod-shaped as well? Well, this is the reason why this thing is such a good idea. Because you can't do that, because the pod has a heat shield at the bottom, and rocket stages have a rocket engine at the bottom. So why don't we just take the rocket engine and put it on the side? And that's what that thing is. Yeah. Yep. I mean, it's pretty crazy. You know, that's... No, here. Here. It's like that face when you know...
I'll cut off your nutsack and nail it to my door! Like one of those lion door knockers rich folks got.
Yeah, Patrick also said that. Yeah, see. It modulates thrust, Reindeer, yeah. It's pretty awesome, actually. Anyway. I think... Okay, so here's another problem here. Problem with this thing that we got going right here is that this thing, it's going to be hard to get the center of thrust to jive correctly. It's going to be hard to blend it into the design to make this thing look right. Actually, let me just mess with this. Let me see where the thrust transform is. The thrust transform on those aerospikes is in a weird spot. Yeah, see, the thrust transform. So where the game says the thrust is coming out of, comes out of the center of the cone. It doesn't come out of the very edge of the cone, which... Because remember, in order to get our design to work right, dudes, we need to incorporate verniers into this design. Oh man, if it was at the point, dude, I could fake it and make it look like the vernier is actually producing the thrust, and it would end up looking exactly like Stokes, which really sucks. But whoever made the aerospike decided that that wasn't going to be the case. Metallic heat shield? Oh, yeah. Yeah, metallic heat shield, man. Actually, reindeer here. I've showed several people this picture, right? But this is from the hop test that I just showed you. Look at that heat shield. So what do you think's going on? It's got ice on it. It's an expander cycle using the heat shield as a heat exchanger. So the propellants go into the rocket's power pack, right? They go through the fluid impellers, and the impellers pump the hydrogen through the heat shield. It exchanges heat with the heat shield, just like an RL-10, right? Comes out of the heat shield, and then goes to individual nozzles here. Like I said, Stokes' engine is ridiculous. Like, ridiculous. It's nuts. Look, that's one rocket engine. One. That, you're looking at one rocket motor. It has multiple nozzles, but it's one rocket motor. One power pack. So, one power pack with a turbine and hydrogen and oxygen fluid impeller, like an RL-10. Only the RL-10 puts the propellants through the nozzle. This thing puts it through the heat shield, which just happens to be near all the nozzles. And that's what drives the turbine. It is crazy. This isn't fair. What's really going to cook your noodles when I tell you that each one of these individual nozzles are throttleable. Individual. They're individually throttleable with one rocket motor. Stoke is the new hotness, dude. There's a reason why I'm trying to make this. That is really freaking cool. It's one of the things I'm kind of most excited about in the industry. So, check this out. We're working on the subscale demo right now, but the other day I completed my VTOL demo to test the landing technology that they're talking about. See if I can make it in KSP. Watch this. It'll probably, now that I said watch this, I'll probably crash, so just... I don't understand what goes on in the stream half the time, but I still feel like I'm learning stuff. Hey, good enough for me, Danglesaur. Whatever. If I get your attention, that's good enough for me. I am a streamer at the end of the day. We love attention. It's how we roll. So even if you're just like, yeah, the reception combobulator. I'm very happy to be here. Totally good, man. All good. You were doing great. Keep it up. So watch this. So that doesn't, you see it. I'm like, it's like, okay, EJ, you made it hover, right? So how is this thing staying stable? I only see roll control RCS there. But also, we're just... It's as stable as a helicopter. It's because I have downward facing RCS that's helping me modulate attitude control. Basically mimicking the differential thrust that Stoke is trying to do. But that's not the only thing. The vehicle isn't symmetrical either. It has 750 kilos of mass hanging off on one side, and it's still stable. Gotta turn the RCS on. See, I told you I'd crash it because I said watch this. Yeah. Huh. We could reuse it. It's not totally crashed. But you see what I'm talking about? Not only did I have to sit here and figure out how the frick Stokes engine works, and don't get me wrong, I had chat to help me out, Reindeer. I had to figure out a way to do it in KSP. And now I have a good working system here that's using cals to offset the thrust controller to take into account the differential mass, because it needs to be asymmetric because that's how capsules re-enter. Stokes gonna have to do the same thing. But if you look, where's the power pack? Where's the turbine machinery? Oh, it's lopsided. It's on one side. So I have to somehow I have to figure out how to make my vehicle asymmetric so it goes lopsided through re-entry so we can roll the vehicle for heat shield angle of attack modulation so I can accurately land it. Okay, Danglesaur, I know you just did the... Long story short, capsules are weighted to one side. That's how they steer them. They steer the capsule, basically changing the angle of attack of the heat shield. So if the heat shield is pitched like this, the capsule will skip off the atmosphere like a skipping stone, and you'll go further down range. If you go more parallel to re-entry heating like this, you're going to slow down. If you go past parallel, you're going to deflect air up, and your heat shield basically turns into a giant spoiler, and it'll force you down. It's something that they figured out in the 60s as a way to keep capsules, to precisely land those capsules, right? So you have an offset center of mass. But here's the thing. You're getting the heat shield to pitch. Putting RCS back here to try and get yourself to do that is not going to work very well because the RCS won't have the crazy moment of inertia to be able to overcome the aerodynamic forces. Basically, there's fire down here, and the fire is coming at you really, really fast. And in order to get the capsule to tilt like this, right, you would need an equal force over here to cancel that out to be able to change it. You're not doing that. There's no way. Right? You'd need RCS that's like 100 feet over here on the end of a thruster and then use leverage to change the angle of attack on the capsule, right? But no capsule can be 100 feet long. No capsule can have like a fishing rod hanging off the end of it. That's not going to work, right? So... offsetting the center of mass makes it so all you got to do is roll. If you twist the capsule like this, because the offset center of mass, it's going to wobble around and it'll change the angle of attack of the heat shield relative to the direction of flight. So in this particular case, with the capsule flying upside down, right? Capsule's flying upside down. The head heads to the ground, right? Capsule actually generates more lift this way, and you can skip off the atmosphere, which is exactly what Apollo, Orion, Dragon, Soyuz, that's what they all do. I understand what you mean, but it takes me a second to dumb down the big words. Yeah, I got you, man. I got you. Yeah, Tim did do a video about Stoke. Yeah, Tim did video on Stoke. Yep. So, not only do we need to do that, I have to get that thing to vertically land. I have to get an asymmetric vehicle to vertically land. This is a tough challenge, man. But this is my prototype to prove this concept. I have 750 kilos of weight or mass attached to the side, and I can get this thing to be as flyable as a helicopter or a drone flying around. So I got the landing stuff figured out. That's fine. Like, doing the actual landing is good. Now I got to figure out how to get that. I got to figure out a way to how to get this thing actually back to the Space Center. And that's going to involve doing something like that, which, yeah, that's going to be a little tough. But we're doing this on a subscale we're doing a subscale demonstrator. I'm doing something that's half of the size that I want the actual thing to be, and that's where I'm at right now. I'm trying to, so with this one, it was really easy to figure out what motors we wanted. Those little spark engines work just fine. Or the twitch engines work great. Now we've gone to scale Project Hemi up even more, right? We've gone to the subscale demo, right? Which means we have to do the whole regime. Launch, get up into space, deploy payload, come back down, be able to steer this thing through re-entry, right? Be able to steer it correctly, and then precisely get it back to KSC, and then do the VTOL and landing part. So I need to take the landing control systems that I just introduced on the subscale, on the VTOL demo, introduce them into the subscale demo, but also make sure that the subscale demo has enough delta V to be able to get where it needs to go. 15 minutes to Starlink. Okay, we'll work on this next week, dudes. I think we'll really jump in on this next week. Good progress was made today with outlining. What I did today was basically outline where, like, the size of the capsule. If you look, all the lines where everything is supposed to be, I basically made a blueprint in KSP. And, yeah. Basically made a blueprint. Hey, Killmeister. Hey, 71, it's my football jersey number, so good luck, I guess? Yeah. I think this tank combination here, I'm just going to leave that there with the arrow spike. But remember, we have to incorporate the verniers into the spike design, that's the problem I was trying to solve. But we're 15 minutes out from an actual rocket launch, and I want to watch that. So, it didn't seem like we got much done in KSP today, but that's actually a huge hurdle to overcome. Next week, we should see principal development of this vehicle. And best case scenario, by the end of next week, we should be able to start building the big guy. The big one. But yeah. I'm just saving all the pictures that we brought up today. I'm putting the Stoke stuff in the SERV folder for my research folders because I can. But we will move into Starlink launch coverage here momentarily. Let's cap the night off with a nice rocket launch. All right. So big guy in November, go tit. You made a typo, so it doesn't count.